All right, hello folks. My name is Michael Collins, along with Nolan Scaife. We are the organizers of the 2024, the second annual workshop on SOC operations and construction, or WOSOC. All right. So the goal of WOSOC is to get a collection of operational people and academics in the same room to talk about the problems that the operational people have and the academics are not aware they can build careers out of. Okay? So the message that I put on the right here is kind of the way that I want you to think about it this year. This is from the Toyota production system. I will mangle it as Genshi Genbutsu. What it means is, at least in the Toyota production system, if you want to know what the problem is, go and take a look at the problem. The goal here is that we've got the people who have the problems here to talk about the problems. Okay? So I would like to thank all of the PC members who contributed to this. If anyone's in the PC, please just, announce your presence and everyone thank them. Okay? All right. Our PC this year, we had 11 academic people and 5 industrial representatives. We had 17 submissions, which is nearly 3 times the number of submissions we had last year. We could actually reject people, which for an academic conference is the mark of achievement. Okay? We also, as another mark of achievement, have people in this room who did not write papers for the conference, which clearly means we're going at all cylinders. Okay? So, with luck, next year we'll have 51 submissions. Well, 50, actually. So, all right. So, a couple of rules of engagement for this. So, for those of us who have, cut our teeth in academic conferences for all this time, this is a workshop where the operations people are peers and not guests. What I mean by that is that normally we bring in somebody from operations to talk about their stuff and be like, oh, great, can I see your data? The goal here is that the folks from ops are coming to talk about their world, their stuff. They've gone through the same review process that everyone else has. They're going to give technical talks on their material. We also have a number of papers provided by various researchers. The papers themselves are live on the WOSOC website. For the operational personnel, the only thing that's being kept is the abstract on the site. Similarly, operational presentations are not going to be, everything is being recorded right now, but all the operational presentations will be deleted after this. And I ask you, for the operational talks, do not take photographs, okay? We have allocated 20 minutes for each talk with a 5-minute question period, but this is a workshop. Clement over there is serving as the timekeeper. He has an advanced high technology system to tell us the number of moments remaining. And given the fact that that was written with a tiny tipped fountain pen, he may want to move to the front row. Okay. Since this is a workshop, we're going to follow a 10-minute rule. Every speaker has 10 minutes of serene, uninterrupted free time to tell us what they're doing. At 10 minutes and 1 second, you can start jumping on the microphones, okay? Now, with that in mind, this is a very full workshop. You will notice that we do not have coffee breaks. We are going to be moving through things at a fairly rapid clip. The thing that we've run into is, one, it's Friday, okay? It's on the West Coast. I understand that there's going to be a lot of people who by 1 o'clock are going to start streaming for the exits. I will be standing in the back. I am bigger than you. Okay? So with that in mind, I elected not to include the coffee breaks. I am not going to weep if you run out at 10:30 to grab a cup of coffee, as long as you come back. Okay? So we'll go through all of those talks at session 1. We'll go through the lunch, keep it a little bit brief. We'll then have, we'll have our panel. Then we'll go through session 2, and then we'll do the closing remarks after that for all 3 of you who are left at that point. So now, a couple of follow-up items. First off, NDSS records everybody at does not break out individual workshops. You've decided to come to the workshop. You did not explicitly register for the workshop. So I've put up a QR code. There's a spreadsheet to sign up, just to give us some demographic information. We'd like to track how many people are operational, how many people are academic, harvest your email addresses, send them to Amazon, make a profit off of them, all the normal good stuff. We will be, over the off year, we will be prepping for the next workshop. We will be setting up a mailing list, having a website, et cetera. If you're interested in volunteering, if you just want notification, either sign on the sheet or mail me at mcollins@isi.edu. Okay. Chris Rodman from the CERT at the Software Engineering Institute will now be talking. So this is an academic presentation, so you are, photograph all you want. This magnificent computer.
Well, thank you. So yeah, I guess just to kind of start things off, my name's Chris Rodman. I'm a senior cybersecurity operations researcher. It's a very fancy title for saying that I travel around the world to advise teams on how to build SOCs, how to build national level CSERTs. What I aim to achieve with the paper that accompanies this presentation is a couple of things. The first is to share some insights with everyone here in the broad community at large on some of the experiences that we found whenever we've gone through and established security operations centers, national CSERT teams, things of the like. But most importantly, I wanted to try to aggregate some of my thoughts, my experiences, and some of the other research at large in the identification, prioritization, and implementation of security operations centers. This slide just basically tells me that I'm allowed to speak about this material. There will be a brief quiz about this slide at the end of the presentation, so be prepared. For those of you not familiar with our organization, though, Software Engineering Institute is a federally funded research and development center. Basically what that means is we're sponsored by the U.S. Department of Defense to do work and research on behalf of other government agencies like the Department of State, CISA. We get to fly around and do all kinds of fun things. Most importantly, the SEI at large, though, is responsible for things like software engineering, systems engineering. The division that I work for, CERT, is responsible for cybersecurity. Who here is familiar with the Morris worm? Yeah, a bunch of hands. Morris worm was the genesis for the creation of our division, one of the very first computer emergency response teams. I work in the security operations division. Again, like I mentioned, we get to fly around the world. We get to engage with international partners. We get to build SOCs from nothing. So what that means is there's many scenarios that we find ourselves in where there's a country or an organization that has no security operations capability. Their security operations capability might be someone that's just adjusting or installing an antivirus on one single computer. So it's the charge of our team to kind of help those kind of situations, enable these organizations to build out their capability and kind of build their capacity and their ability to respond to incidents, to do proactive security, all that kind of fun stuff. So in this presentation, again, I plan to identify SOC services, just aggregate them into a nomenclature that we can all agree upon, prioritize those services. So I will talk a lot about the influential factors that we've found in both our research and our experiences that go into determining what a SOC will do. Most importantly, what a SOC will do first and what a SOC will continue to do as they grow. And then I'll frame it into kind of a phased approach where we talk a lot about the implementation of SOC services and how I can relate that back to a larger organizational assessment. So as I mentioned before, this particular body of research came from one very specific question. In fact, this question came up this time last year, actually maybe a little bit sooner than that, in San Diego during a meeting with a mission partner. They asked me, Chris, what functions or services should my SOC provide? And what do you think I told them? Well, it depends. It depends on a lot of different things. I'm sure that if we took a poll with everyone in this room right now we could come up with a concrete list of what the services a SOC should provide include. Things like incident response, things like vulnerability management. In fact, the 11 strategies that Sandy had mentioned earlier is a very, very good starting point. But there are things that SOCs can be doing more of. So to kind of engage this question and kind of frame this problem into a way that we as academics like to bring a theory to practicum, we searched and compared for high-level service frameworks, and we took our own experiences on what a SOC should perform. Ultimately, what we found is that the various bodies of research differed in many different ways. The first is the nomenclature of how we name things, vulnerability management versus vulnerability for response, and I forget what the other one was. We might find other cases where different bodies of work would be responsible for different use cases. Even furthermore, we found that there are differing interpretations of what a SOC should be responsible for. We find this a lot, actually, in dealing with national level teams where a SOC should be responsible for something called critical infrastructure. Now, in the US, we have a definition of what critical infrastructure means, right? Power, water. Other countries, other organizations have a definition of critical infrastructure that include things like the financial sector or healthcare. So this exponentially makes our problem more difficult when we try to put this solution into practice at an international scale. So we took these three bodies of work to try to fit that use case. We took the SOC CMM, the Capability Maturity Model. For those who aren't familiar, this body of work is a very useful tool in establishing a baseline for what your SOC does and a path forward on how to mature your services. The CREST SOC Critical Function Guide. This one establishes a very, very good set of base level SOC services that should be performed. But then we needed to broaden this out at an international scale. So we included the CSIRT Services Framework. This body of work is published by an organization first, the Forum of Incident Response and Security Teams. When we look at the services and functions of SOC CMM, we see a number of different things. We see services at a very basic level. And what I mean by basic level is they're very definitive in what they mean. Security monitoring, incident management, threat hunting, security analysis, log management. Those are very specific tasks and responsibilities for the SOC. When we start to move out to other bodies of work, what we found was that CREST defines the SOC services as things like proactive detection, incident management, awareness of all IT assets, log management, vulnerability management. And to make the problem even more complex, the CSIRT Services Framework actually defines these services in the form of service areas. So now we may not have individual security monitoring. We have a service area of information security management. We have situational awareness. So we have this higher level of echelon that defines the kind of key categories of where SOC services will be designated to. So what we did is we kind of boiled it down. We tried to define exactly what the service areas were that should embody what the SOC will do. And in terms of figuring out where different things map around, we identified the key services located in the CSIRT Services Framework and mapped those to the other bodies of work in order to get somewhat of a definitive list. So we ended up with 6 key focus areas, and we called those situational awareness, security analysis, security monitoring, incident management, event management, and knowledge transfer. Even furthermore, the reason that we did this was so that we could map this to another high-level framework. So those familiar with the NIST cybersecurity framework, and yes, I know this is for pre-version 2 that was released on Monday, I believe it was. You know that the CSF consists of 5 functions and then some categories and then subcategories within those categories. So we get this really granular effect all the way down. But what we wanted to do was align service areas, high-level service areas, with those CSF categories. And there's reason why here later on in this presentation. One of the most interesting parts that came out of this research was some of the influential factors that we can use to prioritize these services. Now, one of the things that we often have to determine as a security operations consultant team is we have to figure out what the SOC can do for initial operating capability. Do they resolve incidents or triage incidents first? Do they monitor things first? Do they deal with security awareness first? How do we figure that out? I can tell you, I can't talk a whole lot about my use cases, but what I can tell you is that sometimes when we engage with mission partners, we find that the mission partner who is in charge of establishing the SOC will want to do everything up front. They will want to do vulnerability management, incident response, even pen testing, which, frankly, if you're just establishing a SOC for the very first time, that is a lot to do. Now, unless you have, millions and millions of dollars, maybe that's a little bit different of a story. But that is actually one of the things that helps influence some of what we use to establish what that initial operating capability is. So first and foremost, obviously, legal and regulatory requirements. That is a huge factor. There are regulatory bodies that tell us exactly what we need to do for security operations. From an international perspective, this goes beyond just the normal regulations that we see in the US, but things that are applicable at scale internationally. We see organizational culture and risk acceptance. This is actually something I'll talk a little bit more about here in a moment. Obviously, budget. Again, if I have millions and millions and millions of dollars, maybe my story's a little bit different. Security risk assessment for the organization. Existing security controls and infrastructure. So, again, legal and regulatory requirements. If we're dealing with organizations like in healthcare or in finance, we have very prescriptive governance that tells us exactly what we need to do. You need to do a penetration test at least annually, and so therefore I know that my SOC will have to have some skill set, maybe if not doing penetration tests themselves, understanding what the output of a penetration test is. This helps us identify what security controls are required versus those that are nice to haves. Organizational culture, security culture, is actually something that I found to be very interesting in this body of research. Sometimes certain organizations have very little interest in security operations. Who here has been engaged with an organization before? You go and ask them about their security program, or let's say maybe their security awareness program, and they say, what security awareness program? Right. It tells you a lot about the organizational culture and what challenges you might be in for when you're establishing a SOC whenever you don't have things like a security awareness program. And then budget. I like this part of our paper that says the best time to ask for money is right after an incident, which does hold true, but it also influences everything else down the line beyond just the SOC services. This influences things like people, the process, the technology that you get to implement or have to implement after the fact. And let's be frank, open source tools aren't necessarily the cheapest alternative, right? We still need a high degree of skill set for someone to be able to manage and maintain those tools. I can tell you with confidence that I have been engaged in engaged with partners before where they wanted to use everything open source, And when we did a comparative analysis between the cost of implementing an open source solution, it was actually cheaper just to buy commercial off the shelf. Again, influencing factors, security, risk outcomes. Obviously, this gives us some landscape, an idea of what the security landscape is for our people, process, and technology. We know the basic equation of risk in this context, so we can use this to influence kind of those services that we'll pick and choose. And finally, security controls that exist already, infrastructure that exists already or doesn't exist already. What we find is that sometimes maybe an organization has some sort of capability in place already, but it's wrong or it's incomplete, needs torn down and built from scratch again. One thing that I mentioned and where this research kind of goes to is that these influencing factors not only help determine what services the SOC will provide, but it also influences the people that you have to implement as part of those services. What are your stakeholder requirements? Who do you have to communicate with? What's your incident response escalation procedures look like? What are the required skill sets that are needed to enable this security service? What knowledges and abilities do my operators need to hold in order to do things like vulnerability management, penetration testing, incident response? Furthermore, I can't neglect the determination of policies, standards, and procedures that are needed as part of establishing your SOC. If I'm saying to a mission partner, I need you to do incident response, I have to have some expectation that that incident response capability is going to come with an authority to operate, maybe some mission objectives for the SOC, maybe some procedures on how to work with a SIM, how to escalate an incident, who you're going to escalate that incident to. And then the tools. This one's pretty obvious, and I'm pretty sure that we're most familiar with some of this stuff. But not just the tools that the SOC will use, but the data sources that they'll ingest from and the attack surfaces that they have to protect. So when we go to implement these SOC services, we have a few phases. The first is an assessment. Not just an assessment of the SOC itself, but an assessment of the organization. What does our attack surface look like? What controls are in place? I can utilize tools like the CSF to help me determine this stuff. The second phase is analysis. We've defined what the existing state of cybersecurity is within this organization. Now we have to identify what the potential end state is, where we want to go with this security operations capability. We're taking that high-level assessment in this phase and kind of boiling it down to be very specific to the security operations of that organization. The third phase is using those influential factors to help prioritize what those services and functions are for the SOC. Again, assessing things like the organizational security culture, looking at the budget. How many different factors do I have to work with here? Where can I find flexibility? Then we map those functions to some of the priorities. So, in fact, we would say maybe we have a high amount of budget. We could do some more advanced things like vulnerability management right up front. We can do some more advanced capabilities like digital forensics. So we're essentially taking that to-be state, the services that we've identified, and prioritizing them. Then finally, we're planning for implementation. Now, I can't tell you distinctly, yes, this is the phase where we're going to start implementing everything. As we know as security professionals, a lot goes into implementing tools, implementing procedures. This phase just simply identifies the start of the implementation, the need to begin down the path of, yes, I need to install a SIM, but I also need my logging policies, I need my procedures for utilizing that tool, all of these different things. So some key takeaways. We identified some common SOC services between different bodies of work. We identified some prioritization factors, some things that are going to help us to determine what exactly I have to consider whenever I'm establishing a security operations capability. And then I have identified an implementation process, just a high-level set of 5 steps that I can go through whenever I'm going through and establishing that SOC capability. But our work isn't done here. In fact, further research, including one of those, including a body of work that's being led by one of my co-authors, aims to further map people, process, and technology attribute to SOC functions and really make something that's practical and usable whenever we're building out these teams. Furthermore, we can demonstrate common valuation for those prioritization functions. Going back, we know that things like budget are very quantifiable. However, how do I quantify or measure organization security culture? I really can't. So that's an area of focus that we would like to pursue. Furthermore, work towards a framework of SOC implementation, something that aligns with things like CSIRT services framework that we can take internationally, demonstrate abroad. So, some recognition, some accolades. I didn't have my mugshot up front in the very beginning of the slide deck. I saved it for the end. But a special thanks goes to my co-authors of this research, Dr. Justin Novak and Ms. Brianna Kraus. And that leaves us to the Q&A portion.
So great talk. So you've mentioned multiple times, I think, and it's very sort of central to my life, which is the budget. Right? And the budget goes up, budget goes down for no apparent reason. Right?
Exactly. Yes. Yes, everywhere.
So I feel that one of the real sore points for me is that I feel that I'm not making my point across to business. So do you have like samples, templates, assistance on how to make that case so business people can understand, what value they're getting out of the SOC? Because I've been trying over the years and not succeeding.
Yeah, one of the most, yeah, you're absolutely right. I'll start off by saying that organizations often will find themselves rooted in the amount of money that they have. In my experience, even prior to the time before I joined CERT, I can tell you that if you are building a case for a business, usually that is rooted in how much money they will lose if they don't implement a certain capability. Now, again, we typically, in my experience, don't target the cheapest items first. It's more in line with what meets the need of that organization. And sometimes even the person who is the SOC manager that we're working with doesn't necessarily recognize that case. Part of that future work that I had mentioned that one of my co-authors is currently working on aims to kind of fill that gap. So I hate to say, just wait, but we're waiting on, further publication, hopefully, to kind of help those specific use cases.
Thank you.
Mm-hmm.
Hi, great talk. Dr. Chris Fennell from Walmart. One of my questions for you has to do really with economies of scale. So SOCs are expensive, right?
Yes.
And so how do you make the argument of establishing a SOC to where you are actually seeing some of the productivity, like, I'm going to spend millions of dollars this year, and then leadership will say, all right, well, you spent millions this year. When are you getting there? Like, what would you advise, and based on your paper, for economies of scale, kind of a
That's a great question. So whenever basically we're talking about things like initial operating capability and then building off of that.
Yeah.
And we deal a lot with that with most of our mission partners. Because a lot of our mission partners, most times, I can say with confidence that most times when we go in and build a security operations center, it's because an incident just happened.
Okay.
Going back to my point about budget, when do you have the most money? Right after an incident. So in some cases, there is usually some budget to work with. Now, over time, does that necessarily mean I'm going to continue to have that kind of budget? Probably not. The realization of how much things actually cost, like tools, the data that those tools are going to collect, the amount of skilled individuals that are needed to staff a SOC are things that we aim to identify up front. What we found too is that most of the cheaper things to implement first are the policies, standards, and procedures. Those can start to help establish kind of that culture of security within the organization, but then it also sets some realistic expectation of, okay, I now have an incident response capability. I need these policies, but now I need to backfill this with skilled individuals who know about incident response. And again, some of the further work that we're looking into is to exactly how to quantify those numbers based on my initial needs.
Awesome.
All right, everybody please thank the speaker. Now, the next talk is an academic talk. This is Kumar Shashwat from the University of South Florida, right? Okay. Kumar is going to be talking also about generative AI and pen testing.
So, hello everyone. My name is Kumar Shashwat, and today I'm here to present our research, a preliminary study on using large language models in software pen testing. So this is not just an academic paper, we have some industrial collaborators as well. So the paper has been co-authored by Francis Han, Shengming Oh, Dmitry Kolkov, Lawrence Hall, and Jay Legati from University of South Florida. And we have Raj Rajgopalan from Residio and Arvind Tabari from Cypher Armor. So Dr. Raj is the one with the pink hair asking a lot of questions. So this whole presentation is divided into multiple sections. Initially, we'll be talking about what is software pen testing, and then we'll talk about the motivation of our research. Basically, what is the problem that we are trying to solve? What is the problem we see that is there in the industry? And then I'll talk about what we have done and the data sets and prompts that we have used. And in the end, I'll present the results and conclusions of our study. So let's start with what is software pen testing. So software pen testing in very simple terms is essentially trying to find bugs in software. And it is often done by a pen tester. And a pen tester, when they start trying to find bugs in a software, the very first thing that they do is they create a to-do list, a list of actions to perform. And that to-do list is, in technical terms, called a pen test plan. So a pen test plan, this is like a sample pen test plan for an API endpoint where the pen tester is initially performing input validation testing, where they'll try to look for things like SQL injection, etc. And the other one is error handling. So what if something happens wrong with the API and how it is handling it. So when a software pen tester creates a pen test plan, they leverage various inputs and various inputs to create a pen test plan. So the very first thing they leverage is their own experience, their expertise, internet, and then they go through the code files and try to find some vulnerabilities through that. So for example, if a vulnerable version of Log4j is being used, so that is automatically a red flag for the pen tester. And then there are various code analysis tools whose input a pen tester leverages. For example, SonarQube is one of them. So yeah, so a software pen testing cycle does not just end at creating the pen test plan. There are more steps ahead. So let's just say the pen test plan has 100 items to check. And out of those 100 items, a pen tester successfully finds a vulnerability. So once they find a vulnerability, they need to prove it to the development team that, okay, there is something vulnerable, because they won't believe it easily. So you spend some time creating a proof of vulnerability, creating a Jira ticket, assigning it to the right person, and then it gets fixed. So this is a very tedious cycle, and I think this is where we can come. So if we see the pen test plan, it initially had a lot of items, 100 things to check, and the pen tester was only able to find one vulnerability. Is it possible to help pen tester triage into a smaller subset of items, let's say 50 items, or maybe 25 list of things in pen test plan to do in order to find the vulnerability? So one of the things we see is that a pen tester wastes a lot of time looking for vulnerabilities that do not exist. So what are some other challenges? The other thing is more and more code is being generated, so there is always more things to review. There is an extreme shortage of cybersecurity experts. As we all know, there is never enough people in a SOC. Static analysis tools like Sonar, they generate a lot of false alarms. So just to be sure, is anybody from SonarQube here? No one, right? Okay. We'll be talking about it a lot. And the other thing is false alarms is a very big issue. And besides that, an even bigger issue is that they miss out on actual problems, and that is false negatives. The other fifth point, which I feel is very important, and maybe that is why Sonar is like this, is that these tools, they are very generic. They are not catered to the needs of a code base, to the needs of the company, or to the requirements of the management. Like they are very much in general, and they're like one-shop solution for all of those things. So they're very hard to modify. And because of all these things, this pen testing, like actual good pen testing, becomes a very time-consuming and a human-intensive task. So I would like to add here one more thing. Like there are some automated pen testing tools, but those tools as well, they are general. Like they cannot be catered to the needs of a developer, to the pen tester. So one of these solutions we can help is we can help the pen tester create more precise pen test plans, shorter and more with a higher conversion rate to vulnerability. So now the question is, how can we generate pen test plans? So how can we generate more precise pen test plans? So we have a pen tester who is leveraging the inputs to generate a pen test plan. So what we are thinking is, like all these, with the generative AI trend going on, we thought that why is it possible to have like an AI co-assistant work with the pen tester all the time? So let me just give you an example. Let's say this pen tester is responsible for testing an API endpoint, and that API endpoint does not talk to any database directly or indirectly, right? If that is happening, and the pen test plan has like a lot of, pen test plan contains a lot of SQL testing. So the AI assistant can jump into this, it can look into the code, it can look into the plan, and can tell the pen tester that these additional steps, these are not needed. And so what would be the requirements of the AI assistant? So like this slide is very important. You can, this is like the main key takeaway of the entire presentation. So if you forget everything else, just remember this. The requirement of this AI assistant would be that this assistant should be able to understand context. It should be able to understand what the requirement of the code is. It should be able to understand what pen tester wants. And each source code is different. The AI assistant should be easy to modify. It should be able to learn from feedback. So right now there is no tool out there who can do that. Like if you try to give feedback to Sonar, they will take the feedback and they'll do nothing about it for years. And the AI assistant should be able to sustain what it has learned from one project to another. So let's say you spend a lot of time prompt engineering and fine-tuning one particular AI assistant for one particular project. So that AI assistant should not be just limited to that project. It should be able to scale to other projects as well. So one of the technologies that we feel is that can help us, maybe help us build that AI assistant is large language models. And this is what we have explored in this paper. We have seen that how good large language models are when it comes to detecting software vulnerabilities. And we provide it with vulnerable code. We ask it for vulnerabilities. And the second thing that we have checked is how much can we improve the large language models if we give it like more context about the code. So first thing, how good they are in general. Second, if we tell it more about the source code, how much better can they be. So the very first experiment that we did was we had a basic prompt and we had the code and we fed both of those things to the large language model and we asked it, is the code vulnerable or not? So this is the simplest one. Then the second one was we generated augmented prompts. So augmented prompts is basically we tell the large language model more about the source code, more about the vulnerability that we are looking for. And then we saw what was its performance. And then in the end, we did a comparative study with base model, the augmented prompts model, and the Sonar Cube. So one of the major requirements for this was initially we thought that we'll just use vulnerable code, but false positives is a very big challenge to deal with. And if there is a large language model which generates more large language code analysis tool which generates more false positives than Sonar Cube, then nobody will want it. So we wanted a data set which was a combination of both true positives examples and false positive examples. So we found a benchmark from OWASP which contains over 2,740 files, and it has a combination of both true positive and false positive examples. And then later on, and it contains 11 categories of vulnerabilities. And later on, what we have done is we took a whole lot of like 3-4 large language models, and we compared their performance for each of those categories. So you will see these categories: command line injection, weak cryptography, show up again and again. Oh, it moved. All right. So that box is supposed to be at the variable param, right? I don't know why it shifted, right? But anyways. This is an example of true positive SQL injection attack from the benchmark. The benchmark number is 2,740. And so essentially our goal is we do not want the parameter string to get into the SQL query. So parameter is the user injected string, and it could be like a vulnerable SQL query. So if you see the code, the line number 3, it always evaluates to true, and the value of bar is always equal to the injected string by the user. And if you look at the string SQL, this injected string gets in there, and the SQL query itself is vulnerable. And this is an example of a false positive case. Again, the boxes have moved. It is supposed to be parameter. So if you look at line number 2, the value switch target is going to be character B, and switch case B evaluates, makes the value of bar equals to Bob. And now, if you look in the if you look in the SQL query that is being made in the end, the value of bar is Bob, which is always a constant string. So this is an example of false positive SQL injection. So the benchmark contains many and many examples, which are like this. So now that we have the data set figured out, the second thing to worry is the basic prompt. So initially, we just told it that. Initially, we told the large language model that it is a code analysis tool. And then the second thing we specifically focused on, we asked it to reduce noise as much as possible. We are telling it that report something as a vulnerability if you are 100% confident that it can be exploited now or in the near future. And then we told it what the vulnerability category can be. So this is exactly from the benchmark dataset. Command line injection, weak cryptography, etc. Then we provided it the code, and in the end we are telling it that the output should be in a certain format, because in the end we have a Python script which is essentially a scoring engine for parsing. So one of the things we also explored was, because we did not know which LLM will perform better, we found all the LLMs we could use. So we also noticed that this company, OpenAI, they have two APIs to interact with their large language models. First one is the normal way, that is chat completions API. The other one is assistants API. So I think you might have heard of GPT assistants. So this is that thing, the assistants API. And then besides that, we also used Google's Gemini Pro model. So now that we have the large language models figured out, the last step to deal with is generating the prompts, right? Specific prompts. So before even generating the specific prompts, the very first thing that we did was we took the entire data set and we split it into two parts. The 20% was the evaluation set, and the 20% was the training set, and 80% was the evaluation set. So anybody who's in machine learning, this is opposite of that. So there is a reason why we did it. We believe that in real world scenario, whenever somebody wants to create prompts for their specific needs, a human will have to intervene and a human will have to look into the code and make the prompts, right? The problem is human hours are limited and human hours are very valuable. So it's not possible to look through all the code bases. So we just thought that in a real world scenario, people will just look at a very smaller subset of the entire code base and try to project that learning try to sustain that learning into the larger subset. So this is actually the third point which I mentioned. So generating prompts. So this is an example of how we generated prompts for one specific case. This is a hashing algorithm. It's a benchmark. There's a properties file benchmark, and from there it's reading a specific property hash algorithm 2. So we provided it with more context. We told the LLM that only SHA-1 and MD5 are considered as weak hashing algorithms, and because they are vulnerable to collision attacks, and we told it the value of hashalg1 and hashalg2 from the properties file. So I think now's the time for results. The only purpose of this table is to show you that we have done some actual work, and it means nothing. Ignore it. But this is important to look at. So all the points where you're seeing green, that means those models for those specific test case actually perform better than SonarQube. I would want that to sink in for a bit. SonarQube was made in year 2006. It has been optimized for years and years. And there's a tool which we built in a couple of months that is able to match its performance. So it is a big thing, and it shows promise that if it is made in a certain way, if it is made properly, it can actually be really good at this job. Yeah. The other question that we wanted to answer was, is the performance increasing when we are giving it the augmented prompts? Is the large language model improving itself from the feedback? So when I was doing the feedback training, what we were doing is like we only used the reviews from GPT 3.5, and we were like improving 3.5 itself. So if you see GPT 3.5 Turbo shows like very good improvement for most of the cases. So this brings me to the very first question that we want to answer. Can a prompt engineered LLM meet the accuracy of a standard static analysis tool? And the orange line over here, it means it is the Turbo Assistant and GPT-4 Turbo Assistant, and the blue line is SonarQube. So we can see that there are cases, for example, secure cookie, where like GPT-4 Turbo Assistant massively destroys SonarQube. So, and the other question is, how effective is prompt engineering? This is the model where we actually spend a lot of time doing prompt engineering, and you can see that the orange line is way above the blue line, and there are cases where LDAP injection where the improvement is from 12 to almost 42%. And so I would again want to bring you back to the 20/80 split that we did. The prompt engineering that we have done, it was just done on a 20% subset, and these results that you're seeing, these are from an 80% subset. So we were able to sustain all the learning from a very smaller subset to the larger subset. Now the question was, so the question is it able to sustain learning from one data set to another? And from this small chart, it looks yes. But then we tried the same prompts on a different model. And there, the learning was not as significant. There, the improvement was not as significant as others. There is still improvement, but it's not as significant. GPT-4 Turbo Assistant was a little outlier. There is more improvement here. So, why is it not? So yeah, what is the future work? So future work is like we want to use large language models to aid SOC analysts on which alarms to focus on. Look into ways to create larger data set to have more realistic vulnerabilities. And the other thing is there's a limitation of this benchmark that it's in Java. We want to expand it to other programming languages as well. So the conclusion is LLMs, they show a promise that it could be a viable choice for code analysis. And it is they could be a very viable choice for making that AI, pen test AI assistant. The other thing is, like, through our experiments, we have shown that through prompt engineering LLM's performance, it can be improved significantly. And through prompt engineering, the learnings from one model from one data set can be sustained to other data sets as well. So thank you very much.
This is probably just a very stupid question, but I've seen on Facebook that sometimes when people ask for vulnerabilities, the ChatGPT response, this is not ethical behavior, I will not answer your question. How do you deal with that problem?
So, the thing is, like, OpenAI has built filters. So there was another paper called Jailbreak LLMs in NDSS. What those guys have done is, like, you cannot hear me? Okay, can you hear me now? Okay, yeah, so I mean, what happens is, like, ChatGPT gives an output, then there is a filter over there that parses that output and makes sure that nothing bad goes out. So you have to use specific jailbreaking techniques. You have to tell it different various kinds of stories. For example, one of the jailbreaking techniques is you give it a story that you are in a dungeon and you're roaming here and there, and suddenly you find a door which has your query written, how to make malware. You have to make malware to enter through that door. Then it will answer. Like, you have to use techniques like that.
Yeah, my question is along the same lines. So I just wanted to know more about, like, your evaluation, like your experience in the evaluation. Like, did you try those questions apart from the data set? Like, do you know if those data sets were used to train the model? Did you try another model, like open source models like Llama or something like that?
So that is one of the future works. I have looked into this model called Code Llama, and its performance is rough, like on par, similar with GPT-4, but like it's like still ongoing work. Yeah.
Sorry, quick question. Did you try multiple examples for whatever scenarios that you're testing for, or were those the same examples? Or did you write different code for it?
Oh yeah, no. This is just on the benchmark right now,
oh, okay.
and the reason why we did this is, like, it's kind of considered standard between code analysis tools. So we wanted to see how it will compare to the current tools, like SonarQube or any other dynamic analysis tools as well. So that's why we just limited it to this. But this is actually one of our future works. Like, we would want to expand it to create larger data set, actual world scenarios, and test it over there.
So the examples were not taken out of actual vulnerabilities, but you introduced it in a live environment. Is that what you're saying?
So you have to speak a little louder.
The vulnerabilities were not actually in it's the software that gets out to the public. You just created a simulated data set.
Oh yeah, this is essentially a benchmark data set. Oh. Yeah, benchmark data set of vulnerabilities. SQL injection does go out to the public, but and this code contains those as well. But like they are actually quite more obvious about the SQL injections. But like in actual real world scenario, SQL injection is not that easy to detect. It's like that.
Yeah, I was just wondering if the amount of code or the length of the code would affect the results of the evaluation or not?
So-
because in production software is not going to be really concise.
So for that, there are two ways. Prompt engineering has a limit on the number of tokens, correct? I don't know, with Gemini 1.5, they say they have a 10 million token count, but still there's a limit. The other way around is we can have fine-tuned models. With fine-tuning, you can bypass that limit. And with fine-tuning, the model weight changes. So that is also one of the things we can explore, yeah,
Okay.
to bypass that limit.
Yeah, thank you.
Thank you.
All right, thanks, speaker, everyone. So, all right, so we've got an exciting hour and 10 minutes for lunch. At 12:20, we will have our panel. So our panel speakers are Roger Gopalan over there. He's, huh? 1:20, at 1:20, indeed. Look, I recognize that I'm definitely kind of being maniacal on the schedule, but you're right, even I'm not that maniacal. Okay. Myself, Casey Claffey, and why is my brain blanking on the 4th? Well, that's good. Anyway, it's on the list. So Sean, it's Sean. Sean, you should be telling me that I'm going to, you should be pointing that out to me. It's like, you're right there. No, that's okay. I forgot, you forgot, we're both good. Okay, let's go get some lunch and be back here in an hour.
Okay, all right. Well, thanks everybody for coming to the panel today. I'm going to let the panelists introduce themselves here in just a second. But today, the theme for the... Everything okay?
Just putting a cat. Oh, you already figured it out.
Oh. We're trying to keep the light out of the panelists' eyes.
That is a classic example of remediation in action.
Okay, so the theme for the panel today is data sharing across academia and industry. I think, as you all know, and one of the themes from earlier today is that there's a lot of data, that's generated in industrial environments. Of course, as an academic, I also know that getting your hands on any of that data is, almost is next to impossible. So we have synthetic test cases. We try to find what we can from open source databases. We try to, infer what we can from different pieces of literature. But, those things are imperfect in many ways. And so, anyway, that's the topic of the panel today. If each of the panelists will first introduce themselves, name, affiliation. I'll start with you, Mike.
Hello, everyone. My name is Michael Collins. I'm a senior computer scientist and research team lead at the University of Southern California Information Sciences Institute, located in Arlington, Virginia, for my many sins. Okay.
I'm Sean McGee, the CISO of Neiman Marcus Group.
Casey Cleffy. I'm a research scientist at UC San Diego and an adjunct professor in the CS department there. I lead a group called Center for Applied Internet Data Analysis, so we do a lot of internet measurement and data sharing.
I'm Raj Rajagopalan. I work for a company called Residio Technologies. You might know it better as Honeywell Home. We do IoT, residential IoT devices. I am the PCERT leader, if you know what that means. I'm also the product security leader, which means that I am responsible for the security of all our products from conception to all the way to the field. In my spare time, I'm also adjunct faculty where I teach at NYU online on how to be a practical cybersecurity architect.
All right, thanks. We'll start with a softball question for all of you on the panel, and we'll start with you, Raj, since you've got the microphone. From your perspective, what do you think the key barriers are for data sharing? I think everybody recognizes that there's a need on both sides to be able to do that, but what do you think that those barriers are?
So I've fielded this question many, many times over the years, right?
See, we don't need that much preparation.
That was the softball one.
So my answer to this has always been the same. We seem to think of the people we are trying to get data from as the enemy. They're actually our friends. We just speak different languages. So when I go to my business leaders and ask them for something, the key indicator of whether I'm going to get my request or not is whether I couch the request in a way that they relate. And so what happens with a lot of our requests is that we ask for data and we forget to see it from their perspective. It's like, what's in it for them? So if we can create a value proposition to say, if you share this data, this is what you will get in return, you'll be far more successful. There is this myth that there is a wall that cannot be breached. But that's not true. All these business leaders are used to negotiating all the time. So you just have to know how to negotiate with them. I think that is the main thing. We're all technologists, engineers. We don't think that way. We think if you put the facts in front of people, they will just agree. It doesn't work like that. So we have to learn to be better negotiators.
Do you want us all to answer?
I have opinions, but I forget. Do you want to go first? Okay. So I think that part of the issue that we face commonly is, and to hinge on something that Raj said there, this issue of not sharing languages in common and to a large extent not being able to demonstrate in an operational environment that we will provide value. And I think part of that is that, in particular as computer science researchers, we have frameworks for solving problems which are not necessarily the same frameworks that an operational environment will use. And so, for example, one of the things that I ran into early in my career is we would have people from a number of different sort of government research adjacent organizations where we were basically asking, how can we create new signals for the SOC? And the last thing that the SOC wanted was a new collection of signals. Okay, and so I think part of the issue here, and why I'm a big why I decided to go kidnap a bunch of SOC operators and drag them to an academic conference in the first place, was for us to talk about what are the problems that we're actually facing and see if we can come to some common ground on that.
But to Roger's point, it's negotiation, it's risk, right? If I try to share data with somebody, it's going to be a little effort there for me to reduce the risk to where I can share it. And it's going to be competing priorities. So you got to tell me what is valuable in it that's going to make me reduce priorities of other things so I can increase priority here to anonymize the data or make it safe for sharing, and then take the risk that I miss something and share something I shouldn't. So it's going to be a value prop versus all of the other stuff that I have to do.
Casey, do you want to say anything?
Well, we should probably talk about concrete examples, because I think in the cybersecurity space, it's super hard to create an incentive for an industry to share data. I don't know what it would take for me to do it if I worked for a company, because there's really only downside. If anything gets released that sheds light on the company, and it's not their job to support research. So I think if we talk about how to make a value proposition for the company, it would help me if we had some concrete examples of what that means and how it has worked out for some of the companies that have shared data with academics.
So, well, we can talk about some concrete examples. Raj, you want to talk about the work that you and Simon did?
Which part of it?
How did you manage to convince a SOC to take an anthropology student?
Okay. So for those of you who don't know, so Simon led this wonderful, wonderful project where we used techniques from anthropology or ethnography, to be actually more accurate, to study the problems of a SOC and try and help the SOC. So we actually got students who were, I think, computer science students who were trained by an anthropologist to do field work in anthropology, to come and work at the SOC. So how did I convince? Well, like I said, I learned very quickly that, like it was talked about earlier today, SOCs are perennially short of staff. The first thing you offer is free labor. Right? You say, okay, these students will come in and do the job of your entry-level SOC analyst. And, of course, there's skepticism. I said, no, you think you can just walk in and be a SOC analyst? So I said, yeah, well, we'll do some elementary training and vetting, but you have the option to throw them out if you don't like them. So that was the first step. You have to break down that barrier. The second barrier was, okay, what am I going to get out of these guys, right? And so and the third was the risk. So what we're going to get is, of course, an extra position in the SOC that is filled without your dollars being spent. The risk was, of course, information getting out of the SOC, which is the big, like overarching paranoia of a SOC, of data getting leaked. And so we discovered that they were okay with interns because they were employees. They had to sign the same contract with the company that everybody else did. We even got them to sign a special addendum to the agreement about non-disclosure. And so that is all it took. I was very pleasantly surprised that once I passed these barriers, they were willing to let us. In fact, so much so that a year after, I had 2 interns go through a couple of our SOC sites. The SOC director came back to me and said, do you have a third one? You'd like to use them. So it can be done. You have to understand the keys.
So when we did the early development of Silk, one of the things that happened is we embedded ourselves with the operators there. And some of the early tools that came out of Silk, like the set manipulation material, came out because there was an operator who had a specific problem. And what we did is, and this was sort of where we were researchers rather than just straight coders, is we did not solve that specific problem or highly tailored to that problem. We built a tool that addressed multiple problems that they had. And at that point, we did build up a trust relationship. And so I'm not sure how to do that, because it's like, oh, we're an FFRDC, we can have a long-term relationship with the government agency, and you can do everything from there. But it was the fact that we did we built tools that made their lives concretely easier. And some of this was, to be frank, a lot of this was just sort of performance computing problems that were relatively elementary. Take the data, move it from ASCII to binary, things like that, and facilitate things that we would consider almost sort of prosaic data engineering problems, but it made their lives better. And after that, we could they were actually grateful to have sort of a collection of people who were not immediately in the line of fire to think about problems for them.
I mean, you say that, but the bigger problem is most SOC people don't know what their problems are.
Yes.
So it's not like I have a ready list of things to solve that I can go armed with into the SOC. So that's what our anthropologists taught us to do, is that you have to hang around for a period of time to learn and absorb the context and the environment in order to understand what their true problems are that they may not have articulated themselves or even not be in the forebrain. And so we got these students to first just do nothing but participate as workers and observe. And just from observation and water cooler conversations and all that kind of informal trust-building exercises that they call, the anthropologists call them, we got the problems to surface for us.
This man solved more problems because he was hanging out and smoking with DoD analysts every lunch hour. Yes.
This is good every now and again.
Absolutely. So it takes a lot of such things. So, can I say it? I guess I can. One SOC, we discovered that the entire SOC staff went to a firing range on Fridays because that was their off-time activity that bound them together. And if you were a person who did that, you're in. So you have to discover what it is. It's not a given. You have to accommodate, adjust. And then once you're in that trusted circle, then magic happens.
It is a one of us sort of thing.
Yeah.
Intensely tribal, that's all I call it, yes.
Very much so.
Yeah. That is a good description of it.
So in some sense, this is also maybe, we can say that this the topic of the panel, right? Data sharing. This is not data sharing, right? We never were shared any data from the SOC with that people in.
Right.
You can argue with the
Well, I think that sort of the prelude to that is understanding what their problems are. And I sort of go back to the idea that we come in and we say, the worst thing is the smiling consultant comes in and he says, give me your data and I'm here to help you. And I think, again, we go to the idea, tribal, stressed, overworked. They're not going to just produce information on a platter for us. And what happened as we built those relationships was, off of Centaur, we must have graduated 6 PhDs. And that all required building those relationships to the point where, yes, they were comfortable giving us a cut. Now, to be honest, the cut was not the real result. It was the experience and the knowledge that allowed us to then ask, if we were going to construct an experiment as a good set of empirical scientists, what information do we need for the cut? Because again, this goes back to this issue of the risk of releasing the data. What is the value that they're going to get from that? So, okay. Go for it.
Can I just ask, do you have an example of what he's talking about? Because I agree, that's not data sharing. That's like hiring, which is great, and it's operations research, but it's not academic research. And I think that's, if we really want to talk about, and I'm not saying we should, but it is the title of the panel, independent research.
What's the difference between operational research and academic research?
Well, operations research can be proprietary, and not operations research can be proprietary. Academic research is generally thought of as open and publishable.
But we publish. We publish all our findings.
Right. Well, and I think the line is moving here between academic and operations research, because often now when you have a paper that involves academic researchers and industry, or maybe the student went to do a summer internship at a company and had access to the data, the people that are back at the university who may be authors on the paper or are authors on the paper, they never saw the data, but their names are on the paper. Are you counting this as academic research if the data is still proprietary? Where's the line?
But the research is public. It's open.
What do you mean the research is open? Can it be reproduced? It can be reproduced on someone else's data.
There are different types of research, right? So you can, if you look at the medical science, people get patient data from hospital about COVID and they publish, and that's research. It's not much different than that.
It's hugely different because there's a massive regulatory apparatus surrounding access to health data. Mm-hmm. We don't have that for cybersecurity data. So again, I'm curious about an example where you think where it is really data sharing and not really hiring and signing an NDA. And I'm not saying there is any or that there should be any, but what are we talking about?
Yeah, it is the theoretical title of the panel, so I should have a practical answer to it. Yes, Mike, save me.
I will just add a probably a not constructive comment. Place where there's a lot of data that we use in academic research.
So we catch it for the audio.
I'm sorry. So now I can give my not constructive comment to everybody in the world, apparently. But the one place where I feel like academics do have a lot of data to publish on is stolen data sets. To be completely frank, right? Breach password data sets, things like this, that we use all the time. I hate that to be the only example I can think of right now.
It's important to get it on the record.
Right. Oh, no, I don't know how to get that back in.
Well, so actually let's think about a little bit more about that issue of sort of the opportunistic nature of some of the data sets we've got, because a lot of them, I think part of the problem is, if we take a look at sort of, say, statistics, biology, other data sets, they're usually curated from the beginning to address issues like population validity, ecological validity, things like that. We tend to be so happy just to get a data set. So, and when, oh.
There's one here.
Okay.
So, Mike,
I'm feeling attacked.
May I bail you out?
By all means.
So there's two thoughts that come to mind. Mike actually has published off of proprietary data, and going through the organization's publication release process, he was able to have his thoughts and theories and everything codified within the paper, without disclosing the source. Yeah,
Happens a lot.
yeah,
Happens a lot.
that's the thing. I mean, if you're working with an organization, that's a restriction. They're not going to make it free and available for everyone because obviously that's not a really good security practice.
Well, so for example, yeah, we've done like specific and situational data protection rules for those particular projects.
And that's important.
Yeah.
That's what needs to be drawn out, is how it works. Examples of it working, like, I don't know where you were employed at that time or how the NDA governed.
We by the very nature of the process for doing this, we can't disclose exactly who we're working with at that time.
But I think that this gets to the point of the value proposition, which is that sometimes it's the risk that the organization specifically faces that we have to consider with the data release.
Was this government? Was it government?
I cannot tell you.
Okay, let me just say, I don't care, but let me just say, it is different. It is a different scenario if it's the government versus a corporate entity. So I think it is, let me just say, it is unreasonable to expect the corporate entity to share data that could shed them in a bad light. And this is the way that this is managed, is that you hire the person, maybe a 0% time hire, even at the university, to get access to traffic data from the university. Often the way that happens is the graduate student will become an employee of the university 1% time or something.
Yeah.
And then they have to abide by the employee agreement, which
Yes.
seems totally appropriate.
So that's what I think. Yeah,
And
that's-
my second point there was the way that I have seen this work is we're talking about go get the data, but there's a data residency sort of thing that you can consider here is, can you just give us access to your data lake? That way it does not have to be transferred. It removes some of the risks that are associated with the potential spillage of their data sources.
Right.
Things of that nature are things that you should consider, not just say, give me your data, but may I have access to this one small part and this one bit of compute, which I know that you probably want to like throw me off a bridge for saying something like that, but yes, that's
It
another
happens.
avenue.
That's also a model that happens.
Go ahead. Do you want the bridge?
No, it could work. We have contractors, third parties that have access to our data. But then that comes back to they're doing something directly for us. Like I hire a service desk, I give them access to my data because they're going to reset passwords, they're going to help people, do whatever. So it's the same thing. But what's the value if I give you access to my data, access to it? I'll give you the data just to access to it. What's the value? How are you going to secure it? Where's it going to go? How do I know you're not going to be breached? There's a lot there. So then it's right back to where, how do you make that valuable for the company to let them take on that risk, to be willing to try to make that data safe? Because there's going to be risk there regardless, even if you're just giving somebody access to it. Less, but still it's going to be, I've got a lot of competing priorities, and it's going to take me a lot of justification to make that happen.
Yes, but at least your access controls are put in place.
Right.
Yeah.
Yep.
So along those lines, Sean mentioned, the risk or, potentially different types of requirements that might be put around the data. Have you seen any advancements in data security that have influenced maybe what we can do today over what we could do, say 10 years ago in academic or industry data sharing?
There are, from an industry perspective, I can think of some technologies that might make it easier so that it's easier for me to find the data, pinpoint the data, and only allow access to the data that is needed. So the amount of effort and risk it takes, or amount of effort and to reduce the risk is easier because there are tools. But that's assuming I have the tools. There are a lot of companies may not have those. There's a lot of data discovery tool sets now today that you can go and find very, very pinpoint this. I need this data. I need to mask this data. It's easy, but that's money. If you've got it already, the risk may be low enough to where it's a value prop that's easier to justify.
But even assessing the risk can be expensive.
Yes.
And what's the incentive?
So I think it's still early days, but it's a mindset problem. So like Rose said, they're afraid that the company is going to be liable for something that leaks, or the company is going to be shown in a poor light. And even the smallest chance of that means that your request is negated. what is happening now is the advent of data privacy. This problem has walked indoors into our companies, where just by virtue of the fact that we have the data means that we are liable in ways that we didn't appreciate before. And so now people are examining data anonymization, partitioning databases, and things like that. And slowly I can see the mindset changing to say, it's not so bad. The initial reaction to data privacy regulations was, oh my God, we are screwed. But now that with the advent of these new technologies, that fear is coming down. Now, if we could capitalize on that and now also provide ways of anonymizing data, not merely for privacy reasons, but also for cybersecurity reasons, like effective ways of hiding IP addresses and certain signatures, maybe then we can say, just like you're sharing, you think that data privacy data is anonymized, this security data is also anonymized, so you don't need to worry about it so much. I mean, I'm not saying I have an actual example of that happening today, but I'm hoping that will happen in the next 2 years.
I'm going to say that data anonymization is also risk. What if I don't do it properly? And then data privacy laws, you have right to delete, right to be forgotten, et cetera. Now if we're talking about that, now I've got to get more acceptance, like customers have to accept it. So like if I was going to say I'm going to share my data and we're talking about anonymizing it and doing data sharing that way, just because I anonymize it doesn't mean that my customer is giving me permission to share it. It doesn't matter if it's anonymized or not. And then if I share it and somebody gets access to it and they take it, now I can't delete it if I've been told to. So there's data privacy can make it, I would say, in some cases easier, in some cases harder.
Absolutely. I'm just saying we don't need to replicate it bit for bit. It's just the overall idea that this risk can be managed. I think that has finally entered the conversation.
Do you have a question?
From the perspective of someone who is building models for detection purposes and everything, I guess like organizations that just want to share the statistical properties of the data itself would be very useful. That way you don't really expose a lot of the intricacies of your network configurations or whatever. Just having the statistical properties from large organizations or a large number of organizations will help us understand better how the data is, because we can figure out like what the data points are, but to construct data sets, we'll have to have some idea of what they look like in a real environment. I guess one of those things could really help us. Another thing is, I think I've been seeing this more, is the idea of federated learning, where you train models on the data on an endpoint, but you don't really share the model, you just share some portion of the learned parameters. So it will help better generalize and make models that are generalizable to a broader deployment. I guess those two techniques could really help in the data sharing problem we have in cybersecurity, because again, working as an academic, it's very, very hard to do statistical modeling without data.
To the first point, the sharing statistical properties of the data, I would say again, and sorry to be broken record, you have to get concrete with a specific example about, that's true for any data sharing, like exactly what are you talking about sharing, for what purpose, and what are the risks? And you can't do the risk analysis without having the first two. So it really depends what statistical properties, because there are statistical properties we could come up with that would be very bad to share. And one of the issues with using things like differential privacy is that what the data underneath really matters in terms of the risk that you're proposing. So, funding agencies have been throwing money funding at privacy technologies, what you asked about, for decades now. And at least what I've seen in the network research is it hasn't made a big impact on sharing of network research data. And one reason is the technologies aren't a great fit to a lot of the questions that the network researchers are asking or want to ask about the data. And the second is it's still a huge incentive problem to get over the let's jam the hammer into the nail to make it work. If you could make it work, either by modifying the data, or modifying the questions, or modifying the technology. So there's still a big incentive problem to overcome, and I forgot what your second point was, but I bet my answer is going to be the same, because you said something about generalizing. So I'm going to say, no, you have to get concrete first, because every situation is going to require its own analysis and risk assessment.
Well, I think this actually goes to certain questions of experiment construction in the sense that what we really do need, I mean, when we talk about a data set there, is we really should be able to go down and say, these are the independent variables, these are the dependent variables, here's the construct we're going to use. Because otherwise, yeah, I mean, if we take a data set, generically anonymize it, and dump it in the world, we're making a bet that nobody in the future is going to identify a feature that would break that. And so I think what we end up with more than anything else is not so much the data set as the process and the questions around it that have to be clearly defined, because that also forms the risk assessment for the future.
I'm sensing a theme here about sort of the concreteness of the question that's being asked. Is one of the challenges here that perhaps, as a student or as a former student, maybe I didn't know what data you have to know what question to ask you about the data. Is it a case where maybe there's a missing discovery component where folks need to learn about how the operation works and what you might have before asking for data?
I do think that that is the case. I think that one of the things that you learn very quickly if you go from academia into an operational environment is that basically you were totally wrong about everything.
That's why it's good to send your anthropology students to SOC.
Exactly.
It is. It's fantastic.
Yes.
But that might actually be a good value prop. Most of the time, the cybersecurity shops also don't know what data they have.
Right.
And so if you could have somebody come in and tell them what data they have, in exchange for some of it that would be low risk, that would be huge, I would imagine, for a lot of organizations.
Every one of us who's been on a floor has at some point encountered an attack, and the first question we've had is, oh, we just discovered a whole collection of systems that were vulnerable that we did not know existed until the attack happened. Yeah.
I was just going to, I think, pile on to the comment. But on this issue of being concrete, to Casey's point, I totally agree. But I think it kind of goes both ways, right? We academics need to be concrete about what we're asking for and what we really need to do our research. And I would like to suggest that the data holders need to get more concrete about what exactly it is they want to protect. And and I think the answer is what Michael just said a minute ago, which is some unforeseen thing in the future of, oh, I really regret having given out that data.
The data holders
right?
will be very concrete about what they want to protect, and the answer is everything.
Yeah. And so I don't know how to overcome that, because I do think methodologies is studied in the privacy literature and so forth. If you could tell us what it is you're concerned about in letting us see that data, we might be able to answer the question. Right? But,
well, I mean, part of the problem here is, realistically, computer security operational people are tribal. We do an awful lot of stuff. I say we, but an awful lot of stuff is done through handshake relationships. It's at some point we both bled together on something, and now I trust you to share data on a temporary Slack channel that's going to disappear in a couple of days or something like that. There's this general problem that we don't. Exposing anything exposes vulnerability. And if you don't have that trust relationship, that exposure isn't going to happen, period. I think this is all going to turn into an advertisement for an internship program, the way things are going. But that need to build up the trust relationships is critical, because we are dealing with sensitive data here.
So let me do a thought experiment, right? So to answer Mike's question. So the basic problem is your perception of us as a monolith needs to be first broken, right? We have lots of pressures from other people. So we are the friendliest people from the corporate side. There are other people who we have to consider and include in the conversation who are likely to be much more conservative and also less sympathetic to our endeavors. Right? So legal departments will put arbitrary constraints because they don't understand what we're talking about. Right? So that's the first thing we have to worry about, is that if we want this to pass, then we have to give them some kind of compelling, cannot be denied value proposition. So for example, we have to be able to say, we absolutely need to do this, but we cannot. So here's somebody who's helping us to do this, potentially. So you have to consider it. So that's one side of it. The second half, which is also a problem, is that most academics who approached me, for example, have talked about their problems, not my problems.
There was a rule at the SCI that we were not allowed to ever describe anything as interesting. Because that telegraphed, you are now an experimental subject to me and I'm not interested in your problem.
And so, I mean, I'm not saying that it's, the fault is in all of us. It's not just in, one entity. But the fact of the matter is, the incentive structure for conferences are such that only some problems are worth working on or writing about, which is a disjoint set from the set of problems that I'm interested in. And so we have to come to a negotiated agreement that says this is an intersection that's viable. This is the place where you would find it interesting as an academic to work on. It would be valuable for me if you succeeded in your research, because then I can do something I could not do before that I need to. And then we can talk about sharing the data.
You still won't share it? You still won't share it? You'll hire him.
No, I can see myself sharing it. I don't think it's impossible. It's just that we have not even come close to that threshold of considering that possibility.
So my question is, I wanted to try to understand the academic problem more, since I don't understand it. Do you feel that it is hard to get data sets that are more like, for example, raw logs or operating system logs, and trying to get something that's a bit more generic, because you mentioned earlier about getting access to a data lake? Or is the problem more about getting correlated data, whereas an operating system tied to a user or an operating system tied to network traffic, because that's where things get hairy?
You
In
first.
my view, the security, and this is Mike's problem, the security researchers are trying to find problems and solve them, just like the operators. But the operators don't want those problems to be found and published before they're solved. And even, it's also a cat and mouse race. As soon as they're solved, the cat's off to the next thing. So there's just a fundamental misaligned incentive there between the academic researchers who want to publish about security problems that are happening on the internet, most of which is operated by companies.
So I think part of the problem there as well is understanding what the data is that makes up operational activity. So there's a number of people in this room who I would describe as being fairly conversant with NetFlow, for example. And that is a relatively well-defined data set. But these days, when you talk about NetFlow, if you compare, say, what QRadar outputs versus what NetQuest outputs, what you will find is that there's now a whole bunch of specific proprietary varieties that add additional fields, specifically, in fact, for security issues. And that does not change. And then you go to the complexity of, say, for example, what endpoint agents record. And without that information, to be frank, the opacity of a lot of commercial products, it's like if you want to know what the fields are, you're going to have to pay a company to know to access the manuals. Some of those questions are not directly answerable for us yet. And oftentimes what we end up doing is working on either open source or other openly accessible things like generic HTTP logs. So.
I don't know
So
if that
we're-
answered your question. Did that answer your question?
I mean, it answered for the most part.
Mm-hmm.
I'll let me go on Mike's.
I think it answered it for the most part, but it sounds like correlated data is really the problem. Because from my perspective, when I've even worked back when I was in a SOC, the problem always seemed to be is that once you start turning something into an alert, then that's when things start getting way more proprietary, and I don't want this to leak out because I have a owner and I need to anonymize the data, and I have now this story that's being told for a correlated alert versus me sharing, HTTP logs are very generic. That might not necessarily tell a story. Yes, it could tell a vulnerability. I get that, but that is a little bit easier for me to share from my experience than it would be for me to share out full-fledged alert data that's correlated.
I can't speak for the whole community. It's like it's so broad, it's all over the map. I wouldn't say it's mostly correlated data. I mean, we ask, coming from the network measurement community, we ask all sorts of things from operators. And actually, the smaller the thing we ask, the more likely we are to get an answer. We ask yes or no questions. Like, is this the way that your routers are connected, or something like that? And then we also sort of give a lot of preamble of here's what we're trying to do. And it doesn't hurt that we've been doing this for 30 years and nothing bad happens with data that we've been given, and that goes back to the trust relationships. But I think it really depends on the question you're trying to ask, what kind of data you need, obviously, to get.
From an industry perspective, correlated data, sure, I would be concerned. Raw data, I would be concerned that they're going to correlate something. So,
Which they will, and that's the goal.
Right. So at least with correlated data, I know it's been correlated already. If I give away raw data or allow access to raw data, they could correlate something and I didn't know about it and they don't tell me first. And so then that could be concerning for companies too. So it might be, depends on the situation, kind of like what Casey was saying, but I could see both being just as risky as the other. And then on the raw data, in those cases, and maybe with correlated data, I might not know who owns all of it. If we're talking about HTTP logs and it's one business unit over another, I'm not the owner of any of that data. I'm just monitoring it from a like SOC perspective. It's not mine. And so then who do we get permission from? It could be any number of people, and you might not even know them all.
Right. That's good to the point that we're not a monolith. There are multiple stakeholders in the corporate world that have to agree to this. Right? But I also want to point out that it's not like we don't share data. Every company out there has bug bounty programs, for example, right? Where there is a very recognized process where somebody can find something really bad about the device. The only thing they agree to is that they'll let us fix it before they go public with it. We can, I'm sure, create something similar for larger data sets. It's just a matter of imagination and doing it.
So we're out of time. Thank you. I want to give each of our panelists, though, just like 15 seconds, if you would. Like, what's the takeaway for the folks in the room that are looking for challenges to solve here? Like, what do you think the biggest challenge is?
I think that probably the biggest thing, and this is sort of just, we're talking about stuff happening on a much longer scale, building relationships, creating firmly defined asks for the data. And just finding the questions requires building that trust relationship over time. There's a lot of that that is an unanswered question at the moment, but I think the big thing is there's a lot of infrastructure that has to be built for this.
And I'm going to go with coming up with that value proposition, of course, is huge. We've gone back and forth on, like, should we share data? Do corporations care to share data? I think a lot of people that work for the corporations would love to share data. And so it's just a matter of figuring out how we can do it safely. And so it sounds impossible right now, but it's not. And I think a lot of that's going to go back on what Raj was talking about, what Nolan was talking about, like last night at dinner and breakfast. A lot of the problems I have, as Nolan put it, are solved in academia. But they're not solved for me. So be interested in the problems that are my problems. I think somebody here said that too. It was Raj that said that. Be interested in that, and then you'll get a lot more, I think, people that are willing to try to share data safely. Sharing data right now.
I don't want to end my last remark to be bashing the academics, but I'll just say it's hard for academics to share data with other academics. It's just so expensive to share data. And the incentives are similar with academics sharing data. Maybe the threat is, someone finds out that your paper was wrong, the way you analyzed the data was wrong. Well, what's the joy in that? So the default norm is not sharing data of your data sets. Now, the leadership and the publishing folks are trying to push against that, have artifact awards for sharing data and stuff. There is real push to try to improve that, but it's just the incentives are hugely misaligned.
I think the pain of sounding like a stuck record, we have to get out of our tribalism. We have to be able to understand the problem from the other side's perspective. And once we get better at that, these things will kind of become easier to do. Sharing data, working together, publishing results, not jeopardizing other parties' interests. and all those things. And once we get that going, I think then we'll figure out how to actually do the implementation of it. Right now, we are at the very beginning stages of this process.
Okay, let's thank our panelists. Okay, I think we're ready for our next speaker. Seth?
Yep, feel free to take pictures. My name is Seth Hastings. I'm a PhD student from the University of Tulsa, and this is transforming raw authentication logs into interpretable events. So this is kind of a two-part paper. First part, we'll be going over the motivation and goal, as well as the problem statement, and then the actual event methodology. And then in the second part, it's kind of some examples of how that methodology can be used to produce some analysis and derivatives that might be interesting to a SOC or other part of an IT team. So this all started back in 2020 when I was a fresh grad student. My university was making mandatory MFA for the students and faculty at our university, as many were around that time. They were already developing some survey measures to distribute so we could get a feel for how the students were feeling about it, how the faculty felt about it. They're including some psychological constructs to see, what type of people actually respond well to MFA. Do they succeed more or less than others? General usability items, things like that. And we realized, hey, we can send out these surveys, and surveys are great, and there's a lot of great research done with surveys. But how accurate are our respondents going to be? Are they technically trained enough to be fully aware of what's actually going on with their authentication when they report difficulties? Are they going to be useful reports? So we wanted to explore data sources we could use as kind of an empirical backing to those survey responses. So like we discussed a little bit before, our strategy was to send in me as unpaid labor to the SOC to get a feel for how things were going there, what data sources were available, and to build that relationship. We ended up settling on sign-in logs, specifically Azure AD, now Intra AD sign-in logs. And while they were our primary data source, we recognized that we would need to do a little bit of data enhancement in order to get what we were looking for. This is what a downloaded, anonymized sign-in log looks like from Azure AD. That was about 5 seconds of the logs, and as you can see, it's a mess. There's a lot of different stuff going on, and it's not something that you can look at and visually parse out. Okay, here's what's going on with this user. They clearly did X, Y, Z. That applied not only in the research context, but also in the context of working in the SOC, trying to run down alerts and saying, okay, Joe did a sign-in that we think was bad. Why was it bad? What has Joe been doing previously? And how is that different from what they're doing now? And so there's kind of a dual purpose with this enhancement that we wanted to perform on these raw authentication logs. We wanted to scope it to the user authentication experience because we were trying to study the user's experience with authentication. We didn't want to know what was going on in the back-end services trying to talk to each other. We wanted to know what happened in that user authentication experience. We also wanted to create something that was a little bit easier to read, made a little bit more sense intuitively, and embed some domain knowledge so that instead of saying, this user authenticated, they had 3 errors. What kinds of errors were they? Were they the user's fault? What kinds of errors are actually most impactful here? And so we do that through a few things. One is this novel encoding of the primary log attributes. Second is categorization of the errors that are encountered. And then third, we filter our raw logs down to the relevant events and aggregate it into single line representation. So the broad methodology for part 1 here, we take our Azure Intra AD sign-in logs, and this data set specifically spans 3 semesters, spring of 2022 to spring of 2023. So we have all the sign-ins for the university from that time. We reduced about 62 million raw rows of authentication logs to 1.7 million single row authentication events across our 7,400 users. So per semester, it's closer to 6,500 users, but in total, around 7,500. And the broad process there, you can see, pretty straightforward. We de-identify the data. We row code the data, which is our primary added identifier that enables us to do the rest of this process. We then reduce the data according to those row codings, and then collapse it into these single line representations. This is a little example with most of the attributes suppressed. But you can see we've got 7 or 8 rows of data on the left. We add a row code to them, and then use that row code to filter out what is actually relevant to the user experience and aggregate that into a single event. And we'll discuss that in a little more detail. So how do we actually construct these row codes? Because they are the backbone of the system. Well, broadly speaking, every log entry in sign-in logs falls into 2 categories. One is a pass, and one is non-pass. There's some issue. So either the authentication went successfully, or there's an error code. And that error code could represent some interrupt that's totally harmless, doesn't impact the user, or it could represent an actual error, whether that be a backend error, a user error, or otherwise. So for the successful entries, the pass entries, it's pretty straightforward to break them down. We simply split on the authentication requirement, single versus multi-factor, and then we split on the type of credential they used. So whether that be a token, a password, second factor, we split on those things and group them to form 10 different unique types of success row codes. For the error entries, we had to do a little bit more legwork. We had to document every error that appeared in the data set, pull all the documentation available for each of those, and then independently code them into a few of our categories that we developed for this. We grouped those by theme and category to form 36 unique error row codes that capture basically 36 different types of errors, broadly speaking. We group them into 4 main categories, and the big dichotomy here is between user errors and configuration errors. These are the errors we really care about. Interrupts are errors that are non-errors. They don't actually stop the user from doing anything. The user typically isn't aware of them. It's little flags for the backend system or redirects that are an expected part of the authentication process. If you go to a website and it rejects your token and instantly sends you to sign in, that's not negatively impacting your authentication experience. It's just recognizing, hey, this person needs to sign in. So that would be an example of an interrupt that doesn't really fall into a real error category for us. There's a couple examples of user errors there. Sign-in error code 500121 indicates that someone failed to complete their MFA prompt. This is something that's both user-caused and user-fixable. So the user has an agency in resolving this error. They're the person that caused this error. We expect them to be able to succeed with that from time to time. Configuration errors are the opposite. The user may not have directly caused it, and they don't actually have the agency to resolve it. Things like signing certificates, user isn't going to be able to interact with that in any meaningful way, or some transient error on the back end where their request just didn't go through. That's not something that the user is able to resolve. And then the final category there is hacking errors, which for our purposes here were just any sign-in error that referred to malicious behavior on the part of the user as flagged by Azure AD. So returning to this example, row code 25 there that you see is simply a user failing to complete their MFA. Row code 20 is a user being directed after successfully completing their password. And then row code 4 is the full second factor completion, which reduces down to a single event with one user error. So the events are made to capture a couple of different things. One, basic session information. You want to know the user, the device, the browser, the application. And then you also want to know things like the MFA requirement and the form. And this is where we start to bring in our derived attributes. So we have error composition. These are user versus configuration errors. So what happened in this event? Was it due to the user making mistakes, or was it due to other things? And then these two measures here, time elapsed and time away. Time elapsed in this case is the time from the first log entry of this interaction to the last log entry. In some cases, this ends up being 0 seconds because we get one entry and that's their successful authentication. There's no issues. So for us, it's more of a measure of friction introduced by errors and interrupts. The second measure, time away, is the time between a failed authentication attempt and the next successful authentication. So this starts to measure things like work productivity loss. If someone is supposed to be doing work and they try and authenticate and they get locked out and they can't, how much time are they actually away until they're back and at work? There are a couple of examples here that I can just talk through. I'll just talk through the first one for time's sake. We see someone failed to authenticate. They use app notification as their MFA type. They entered a password one time. They spent 60 seconds during this authentication event, and this failure resulted in a 7-minute time away. We see 1 user error and 0 configuration errors. And if we were to see the rest of the attributes, we would know that this was a user who failed to complete their MFA prompt, likely because they didn't have their phone on them. And so it took them not only 60 seconds for that prompt to expire, but it took them a few minutes to find and charge their phone before they came back to authenticate. So that's just an example of some of the attributes there. Part 2, we'll go into a brief demonstration of some of the analytics that we can get out of this and some of the derivative metrics that we can create. The first most intuitive thing to look at when you're talking about sign-ins is success rate. How successful are people at signing in? And one of the first things we looked at there is how does this differ by error type? What we found, unsurprisingly, was that these configuration errors are higher impact. 80% of users never succeed when they encounter a configuration error. They just don't have it in them. There's no, oh, let me try and authenticate to a different application, see if I can get around this problem. It's usually just a stone wall. And over 90% of all the events that contained configuration errors were failures. So they just typically present a large obstruction to the user. Conversely, user errors are lower in impact. Very few users will never succeed with user errors. Most people can struggle through, and if you put in your password wrong, you can put it back in and you can repeat that until you get it right. And then lastly, these configuration errors are much more rare than user errors. Over 90% of users experience user errors, and less than 30% experience configuration errors. One of the first derivative metrics that we made for users is flagging when they are locked out. For the purposes of this study, we defined locked out as someone who had tried and failed to authenticate multiple different times, and that time since they were last successfully signed in was also greater than 12 hours. And using that on our data set, the numbers were fairly stable across 3 semesters, with around 150 unique users being locked out in a given week. And if we raise that to a 24-hour period, then it's 105 users a week. Next, we created some app-based derivatives. So one is an early flagging of struggling applications. Then we define struggling applications as any application that suddenly did 50% of its typical success rate. For us, that was Teams most weeks, and in surprise to no one. And we on average had at least 2 struggling top applications per week. So out of the top 20 most used applications at the university, at least 2 of them on any given week were performing below 50% of their standard performance. So being able to early flag these things and figure out what's going on can be very helpful. Next, a little bit more close to the heart of SOC operators is finding applications that are lapsed. And by that we mean applications that have no successful authentications across the time period, in this case semesters. In our university, we found over half of all applications for that 3-semester period just weren't used at all. People would try and authenticate to them, but they didn't have any successful authentications. And all of these applications that aren't being used represent a significant threat in terms of, hey, we've got double the applications that we're actually using, and who's to say if we're actually maintaining these other applications well? If something does go wrong, how would we know? Because no one's using them. So just another example of some metrics that we can create from this. There's a lot of concurrent and future work going on to mature this. This is pretty preliminary work. I didn't include a related work section today, but most of the research that I've read in this area is more in the realm of log aggregation, and there's actually very little work in terms of processing authentication logs and creating user-centric measures from that. So there's a lot of work that we're trying to do here. The first piece of concurrent work that I wanted to talk about is a paper that we're shopping around now on user cost of enterprise multi-factor authentication policies. So we took this same time period and we looked at a few different organizational changes that were made to the way multi-factor authentication worked. And we were able to find statistically significant differences in the cost to the user. You say, hey, we changed our MFA policy for the app to where instead of just a simple deny or approve, you now have to, okay, what number do I put in? I put in this number, then I click yes. And that actually changed things significantly for those users. Policy changes are one thing that there is not enough, how do I say this? It can be very difficult to pitch security changes to leadership unless you can tie dollars and cents to the changes you're trying to make, unless you can quantify the impact. And so this work is a step in that direction of saying, what's the impact to the user? What are different ways we can quantify that? And how can we do that effectively? Next, some of our concurrent work is developing and deploying a dashboard in the university SOC using this event methodology. So back when I was interning with them, running down alerts was pretty difficult using the raw sign-in logs because they're very obtuse and hard to parse through. I'm really excited to see how the people working in the SOC respond to an event log that is line-by-line readable, that is easy to generate distributions of past behaviors on, so that if I get an alert on Jobab, I can very easily look at Jobab's history and see what typical uses are. If all of a sudden he starts running into errors that he never did before, that might not be Jobab anymore. Lastly, some future work, validating the accuracy of this method to the user experience through a diary study. A colleague of mine is working on that right now. He'll take a bunch of users through a several-week period, I want to say 2 months, where they document their authentication experiences. And since we're capturing the backend data at the same time, we'll be able to compare directly and say, hey, how accurate is our measure to their experience, and what can we learn from that to inform future work? And then lastly, maybe a little bit closer to the hearts of everyone here, I have big plans for investigating this less noisy data set that's really scoped into user behavior, actual user actions, as an input for various IDS purposes. And I'm pretty excited about that one. That's all I've got for you today. Thank you so much for listening, and are there any questions?
Lovely. Is the tool available?
It's not available. It's in development.
I'd love to use, I'm drowning in raw logs. I'd love new ways to aggregate them and extract significant information from. How generalizable is it? So, authentication is not the only event of interest. There are other kinds of interests. There are also different kinds of authentication. So, for example, can I use this on my API usage? So is it easy to change your schematic to address one of those other problems?
In my head, the answer is yes. We haven't gotten so far as to actually validate that yet, but it was definitely designed with that intention in mind. And the key kind of domain knowledge required to replicate it is the attributes of interest, which in our case are things like the application, and the multi-factor authentication details, and then the categorization of the errors. So domain knowledge about all of the errors that might be encountered, and efficiently putting those into meaningful categories is a big part of it. Yeah.
Okay, I have all that, but I don't have the tool.
Yeah.
So I think you would find VPN logs also very interesting for this. There's a sort of, for lack of a better term, syslog-y flavor to this kind of information where you've got sort of different processes or different multi-stage processes that are dumping information quasi-asynchronously. There's sort of a time dependency, but it's not a good one. That would be interesting for this. But the thing that would also be interesting for you to consider, I think, would be it's not just about reading the logs, but it's also about what are the practices for creating quality logs for security analysis. Because I think that what happens is when you do this kind of aggregation, you end up with a qualitative analytical difference between what you could do beforehand versus now. And that, I think, is a good area to explore.
Yeah, and not only that, but Azure AD has changed the format of their sign-in logs 4 times since I started the work. So
That's just welcome to enterprise software. That's just going to happen all the time. You're just going to have to deal with it.
Thank you. I appreciate that.
Yes. Yeah.
Thank you.
Raj, you said that you were drowning in logs. Are you drowning in logs you're willing to share? All right. I think we're ready for our next speaker. All right. Matt? Nope. What's going on?
So we had to rearrange slightly because Rakesh and Dave need to leave early, so they're going to do their 2 talks next. I was going to grab you ahead of that. I apologize.
And they're already next.
Well, they've got 2 talks. They've got that in the ORTSOC talk.
Oh, yeah.
Okay,
Okay, yeah.
yeah.
Okay, all right.
So
I'll go away.
both talks are considered academic for our purposes, so you can take as many photos as you want of Dave.
All right. I brought a jacket, but I couldn't be bothered to put it on. Sorry. So, hi, I'm.
We get the wrong slides, so we need to switch the presentation now.
Oh, 10 then 10A. 10 is the log base, is the log analysis. 10A is ORTSOC.
Okay. Matt.
Yeah. They're the same people giving the talk. So
we'll let Matt lead this talk.
Okay. Sounds good. You guys okay?
Yeah.
Yeah. Okay.
All right. Thank you, everybody, for being here. My name is Matt Jansen. I am a former master's student at Oregon State University. I'm here with Professors Rakesh Boba and Dave Neven. And today I'm going to talk about our paper, A Comparative Analysis of Difficulty Between Log and Graph-Based Detection Rule Creation. Let's get started. So starting off with some motivation. With the increased prevalence of technology in our daily lives, we also have the increased rate of cybercrime. Is this better?
Yes.
Okay. In Checkpoint Security's 2022 report, they noted a 38% increase in global cyber attacks globally. And in Mandiant's 2022 threat report, they noted 238 newly identified, they identified 238 newly tracked and observed threat groups. In Mandiant's report, they also noted that a majority of initial access vectors used to gain entry into organizations' networks were advanced exploitation techniques, such as software exploitation and supply chain compromise. And it doesn't help that even today, EDR, or endpoint detection and response software, it still has trouble detecting well and understood threats. In reference number 3, on the slide, the authors are able to show that they're able to use DLL sideloading, a technique known since at least 2017, to bypass 9 out of the 11 EDR solutions which they evaluated. So with this, it's really clear that even today, being able to detect threats at the endpoint is still a very important problem that needs addressing. So, over the past decade, there's been dozens of papers that have been coming out trying to incorporate data provenance into the intrusion detection process. These are called provenance-based intrusion detection systems, or PIDS. Now, these are a synthesis of several different concepts. I've shown a visual here kind of explaining how data provenance integrates into PIDS. And it starts with data provenance itself. Data provenance is metadata associated with a data point or several points in a data set, detailing the initialization of that data point and how it changes exactly over time. This isn't a cybersecurity concept, but rather a general data science concept, and it's good for identifying hidden relationships in these data sets. So taking data provenance and applying it to endpoint audit logging, we're able to understand how system entities are created and how they interact with each other over time. Oh, sorry, getting ahead of myself. And taking endpoint audit logging in the form of system provenance and putting it into a graph format, we're able to get better interpretability, and we're also able to open up analytics to graph algorithms. These are called system provenance graphs, and through taking these system provenance graphs and mixing them with threat detection and attack investigation, we arrive at provenance-based intrusion detection systems. Here's an example of a system provenance graph where we have several typed or colored nodes separated by or connected with directed edges. We have the gray ones representing endpoints, green representing processes, blue representing files, and red being network sockets. We have definitions of node P1 and edge E8 to the right, showing that process is the executable curl, and E8 is a write system call. So we see that edge goes to a blue file node. So from that interaction with P1 to E8 to F1, we can see how curl writes data to a file. So as I said, we have, PIDS, dozens of papers being proposed over the years for graph-based threat detection and investigation. But what's the benefit of it? Well, first, it gives us the creation of a completely connected system history. So from boot to shutdown, we understand exactly what's going on in the system, what entities exist, and what relationships are occurring between them. We also have the added benefit of causal analysis. So we're able to better understand whether or not an event occurred because of a data or control flow from a prior event. And we also have the added benefit of forward and backwards tracking from a particular point in the graph, which aids an analyst in performing root cause or forensic analysis. But are we there yet? Do we see PIDS being deployed in enterprise networks today? We do not. So recent research has actually shown that PIDS are actually a bit too costly to be deploying into enterprises, either client-side or server-side. But this research also does bring up great points for being able to make adjustments for future work to make PIDS something more enticing for organizations to deploy into their networks. All right, so in our work, we want to pay a bit more attention towards the analyst's usage of PIDS. So to do that, one of the related works that we looked at, one of the areas that we looked at was PIDS analyst workload reduction through attack investigation and alert triage. With attack investigation, we have analysts using PIDS to perform that root cause and that forensic analysis. And for alert triage, these works also use PIDS to prioritize which alerts should be investigated first, and also which ones should be ruled out from the alert set due to potential for being a false positive. We also took a look at another area, not specific to PIDS, but general SOC-based user studies. So user studies taking a look at SOC analyst tooling and processes. So we looked at passive studies, which we defined as just general questionnaires or interviews with SOC employees, and also active studies where the participants of these studies were performing some technical tasks such as attack investigation. Now, in this work, what we want to do is we want to kind of bridge the gap between these two fields. We want to take a look at the analyst's interaction with a rule-based PIDS system, something that's not, in enterprise networks, something that's kind of only really proposed in research right now. And we want to kind of understand how more or less difficult is this to use compared to what you actually do see deployed in enterprises. So for this research, we had a few different objectives. First, we wanted to define what difficulty means in the context of detection rule creation. We wanted to assess how much effort is actually going into this process, and how can we compare this level of effort between the conventional methods and the methods proposed in research. We also performed a qualitative user study in which we asked participants to create log and graph-based rules for a particular attack scenario. In this context, log-based rule refers to rules that match patterns of attacks seen in log files, and graph-based rules refer to rules that match attacks seen in system provenance graphs. And again, we're taking a look at how much more or less difficult it is to make a graph-based rule as compared to a log-based rule. And we also want to take a look at rule effectiveness. So, what's the detection accuracy of these rules? What's the false positive count? And we also outline future work, which we believe is really important for, again, bridging these two gaps of things that are proposed in research that are supposed to help analysts, daily lives, their workload, compare it to what they're actually, doing. All right, so a quick overview of the study. Again, our goal is to perform a comparative analysis between log and graph-based detection rules. Trying to understand how much more or less difficult it is to create graph-based rules as compared to log-based ones. For our setup, our study was IRB approved within our organization. We met with participants in a one-on-one setting over Zoom, and when they entered the Zoom room, we would give them a Qualtrics link where Qualtrics was the host for the entire user study. So of the 13 participants that were in the user study, all of them were college students who had an academic and career interest in cybersecurity, as well as recent graduates who were early in their career for cybersecurity. Most of the participants already had Tier 1 or Tier 2 security operations experience, even the college students, through working at the organization SOC. Additionally, for recruitment, we mainly recruited through sending announcements to on-campus cybersecurity courses, sending announcements to our organization's student cybersecurity club, and also direct messages to students that we believe would be interested. So the workflow of this study, once the participants got into their Qualtrics link and signed their consent form, first, they went through a pre-survey questionnaire. This asked a variety of questions related to computer science and cybersecurity topics that are related to the process of log and graph-based rule creation. These topics included regular expressions, log analysis, Linux operating system, and graph databases. So next, the participants had to watch 25 minutes worth of YouTube videos where they watched tutorial videos which first depicted what Linux Audit D was and how it logs system events in Linux. The tutorial videos then listed
how these system events can be interpreted as graphs where the nodes are system entities and you have relationships between these entities. And then finally, these videos talked about what they're going to be doing in the study. So we wanted them to make log-based and graph-based rules for each of the attack scenarios, including the syntax for how they were supposed to do so. And this is a big simplification because, like I said, 25 minutes worth of YouTube videos. Next, they actually went through the rule creation exercises. So we gave them 3 exercises of increasing difficulty. The first one was easy, the next one was moderate, the third one was harder. Each of these exercises, so like for the easy, we had a category of easy exercises where there was 3 that could have been chosen from, and 1 was just picked at random to be presented to the user. And then finally, the users went through a post-survey questionnaire where we asked them questions related to log-based and graph-based rule creation process separately, but also comparing the 2 together. Here's a quick list of the attack scenarios that we presented. We tried to do like an even spread of MITRE tactics, but we also tried to make each of the attack scenarios equivalent enough in context so that, let's say, scenario ID 1.1 was close enough in effort to creating a rule for 1.2 and then similar for 1.3 and similar for the other categories. Now, I'm going to give a couple examples, or an example of rule creation exercise for a particular scenario. This wasn't actually in the study, but it's just an example of what could be expected. That's actually not the slide. Okay, never mind. Sorry, just one moment. Okay, so now I'll focus a bit on what was actually provided to the user in these rule creation exercises and what we actually expected from this user, or from these users in return. So no matter what rule creation exercise they were given, always given a description of the attack scenario. And they were also provided with a cheat sheet, which is kind of like a summarized version of what they saw in the YouTube videos. But specifically for log-based rule creation exercises, we provided them with a Linux audit D snippet indicating the attack behavior. And we wanted back from them in syntax of comma-separated key value pairs of what was presented in the Linux audit D log. And for the graph-based rule creation exercises, we provided a system provenance graph indicating the attack behavior, similar to what was seen in the Linux audit D snippet. And in return, we wanted a graph representation in the form of a Neo4j cipher query, the syntax for which was explained in the YouTube videos. Now, in terms of metrics collected for these rules, the 2 kind of big metrics that we looked at were rule creation time and rule length. We believe that these 2 together would, taking a look at these 2 together would give us an idea of how much effort was required for this rule creation process. But also another important aspect that we collected was from the post-survey questionnaire. We got free-form responses from the participants, basically asking like, hey, what are your thoughts, for both of these processes? So they weren't limited to just the specific questions that we were asking about. So these 2, rule creation time and rule length, in combination with their free-form responses. Here's an example of a log-based rule creation exercise where they're given an audit log snippet. And then in return, we're asking for that specific comma-separated key value pair syntax. And then here's a similar exercise. Here's like a similar representation, but in the graph-based rule creation exercise. We can see we have a couple different system entities connected by, the relationships indicated by the edges, and then the resulting Neo4j cipher syntax that we expected from them. Now, starting our analysis of difficulty, with regard to rule creation time, we found that in general, it took participants longer to write the graph-based rules as compared to the log-based rules. We saw in general, like as the rule creation exercise increased in difficulty, this gap needed to write the log-based rules and the graph-based rules kind of spread out. So it took longer and longer to write these graph-based rules. We saw a similar trend with rule length, except graph-based, when they were writing their graph-based rule, it actually started off, they wrote shorter graph-based rules as compared to log-based rules. But as we got to moderate and the hard difficulty rule creation exercises, they needed more and more time to write those graph-based rules. And then with regard to the post-survey questionnaire, we found that a majority of the participants found that both the log and the graph-based exercises were equally difficult. However, with regard to usability, most favored graph-based rule creation exercise process because they were able to interpret what was going on a bit better. Sorry, those tables popped up at the end. But one other thing to note is that the participants also noted that, they admitted that they took more time on the graph-based rule creation exercises. They were able to understand, like, hey, this takes longer for me, it takes longer for me to write, it's more characters, but I like it more because I'm able to understand a bit better what's going on. Now, with regard to effectiveness, for our analysis of effectiveness, for the log-based rules that they wrote, we used WOSOC as the endpoint detection software. So we specifically used their log test utility and customized it to take Linux audit D logs as input so that they could, so that WOSOC log test could analyze the Linux audit D log in comparison with the rules that the users wrote. Specifically, the rules that the users wrote were parsed using custom Python 3 scripts into the XML format that is accepted by WOSOC. Now, for the graph-based rules, we first use a utility called Spade in order to transform the Linux audit D logs representing the attack behavior into a Neo4j graph database. And from there, we transformed the user's graph-based rules into proper Neo4j cipher query syntax using custom Python 3 scripts. Now, with regard to accuracy, we found that both, I'm just going to do that so the numbers can pop up. So with regard to accuracy, and when I say accuracy, I mean just how many detections were made in comparison to the total number of exercises. We found that both log and graph-based rules were fairly accurate from the participants. When there were mistakes, it was because of simple typing mistakes, like writing a bad regular expression or mistyping a file path. With regard to false positive count, though, we're able to find that with the graph-based rule creation process, there was less false positives compared to the log-based rule creation exercise process, or the log-based process. It's important to note that the standalone WOSOC agent doesn't perform like inter-alarm correlation, so it can't do like if this alarm happens, or if this alarm happens, if this alarm happens, then this, then this, then this. It doesn't do that, so it's kind of hard to make a direct comparison against graph-based because from the native implementation of the graph, that is how the graph is defined as just a set of relationships between entities. So future work can be done to make further investigations into that kind of distinction, but this is the, what we were able to find through our analysis. So in conclusion, With regard to graph-based usability, there was definitely additional overhead with regard to the rule creation time and the rule length. And although the participants noted that they took longer and a few even noted that the graph-based syntax was especially painful, there was increased interpretability in the sense that they could see what was happening. They were able to visualize those entities and relationships. With regard to accuracies and false positives, there was similar detection accuracy ratio, but with graph-based, we were able to see a potential for fewer false positives. Now, some limitations of this study include a small sample size and limited attack selection. We only had 13 participants, so our analysis was limited to that of qualitative nature, and we only had we only had 9 attacks that we kind of chose from. So for future, we'd like to see larger scale active SOC studies where we're actually comparing analysis of tooling and procedures of what is actually being used in enterprise networks and compared to what is being proposed in research to see like, hey, is what we're proposing actually going to have an impact on these analysts? In addition, kind of more specifically towards PIDS, we'd like to see larger scale evaluations against EDR. So far, PIDS prior work has kind of mainly focused on, this PIDS versus a few other PIDS, or this PIDS against one EDR solution. There hasn't been like a larger scale evaluation of PIDS. And a lot of that is due to, like I said, there being dozens of these proposals over the past decade, but there only being enough open source implementations for me to count on one hand. So a comparison of efficiency and effectiveness of these would be especially useful for the academic community. All right, I'll open up to any questions.
Great talk, thanks. I think part of the challenge with graph-based like data provenance solutions is that there is practically nothing out there that does that except for a few things like Camflow, for example, which the performance of may not scale to an enterprise level. I'm not sure about that, but it's really only available, as far as I know, for like Linux-based platforms, and I think that tends to be a challenge when you're looking for like user behavior, or you're looking for like how data is flowing through your network and things like that. And so if the availability of those things were improved, there might be more data to actually look at from a graph perspective. And I think that's why EDR technologies are so pervasive, is that they're the thing that's available.
Yeah.
And so I think there's sort of a chicken and egg problem here with data provenance research, and that in order to get more data, more graphs, more information to look at, especially from industry, you also need those technologies to be available and be used. I'm curious, though, if you've seen, like, are there other challenges that you think, usability is obviously one concern here, and I think it sounded like you sort of nailed it in terms of like, okay, well, instead of like pattern matching against a log entry, this is more of a composite of behaviors, which might make that harder. Are there other things that you think might be precluding the availability of graph-based, data provenance solutions?
Great question. I agree. I think that you kind of have to, I've kind of, in this research, I took a look at, I kind of shone a light on, hey, analysts haven't really been taking a look at, how they actually use this tooling. And, I think even then, that's just one part of it. Going from, like you said, with Camflow, starting with endpoint logging efficiently to this graph format, and then being able to store it ingest it into, not just for one endpoint, but across an enterprise. So that's storage. And then you have the problem of doing for this large graph data set, doing, large scale graph analytics for detection and attack investigation and alert triage. There's quite a few issues, and I don't think I had quite a few slides, or it was one slide, but it asked are we there yet? And it referenced a paper. That paper actually went out and interviewed a bunch of security engineers in industry. And this was mainly based out of China. And there was actually a few organizations out there that do deploy PIDS. And they were able to identify hey, here are the issues that we have. And then they also interviewed security engineers who didn't really deploy PIDS, but are familiar with it enough and have enough experience in industry to say here's what is preventing us from doing this. And they include the topics that I just mentioned, but they also have some really good other points too as well.
Thank you.
Yeah.
Hi, nice talk, nice paper. Thank you. Do you have any statistics about how much errors were made in the first try when they were writing these rules, event-based versus graph-based rules? Because you talk about how you correct the rules to have the correct syntax, right?
Yeah.
And well, a zero-shot rule writing is kind of interesting because maybe some of the times the analysts will write a rule saying that it's good enough and then never bother about it.
Yeah, so thank you for your question. So I don't have statistics on me right now regarding how many syntax mistakes I corrected. So just a bit of background first. When the participants gave rules to their exercises, before they actually submitted them to Qualtrics, we would check them first and see if there was any syntax issues. If there were, we would correct them. We would ask them to correct them, and then we would keep asking them until they gave us a syntactically correct answer. If they gave us a syntactically correct but semantically incorrect answer, something that's okay, I see this rule, this ain't gonna detect anything, but we'll take it, we let it pass. So to answer your question, so there was a mistake in the cheat sheet that kind of misaligned with the YouTube video. So we couldn't kind of take those, as, we couldn't use that data, essentially. So it was mainly a correction process just to make sure they were giving us syntactically correct rules. But for future work, I think that'd be huge to hit on because as that one participant said that I noted earlier, graph-based syntax is kind of a pain. You have curly braces, square braces, parentheses. So, yeah.
Did you find any insights from the participants that maybe indicated whether that syntax was maybe difficult to work with, or?
Yeah, there was those few participants that said at the end of the day, you are taking information from one source and you are putting it into another format. Okay, that's the same. But with log-based, it's easier. It's comma separated. Field equals value, comma, field equals value. With graph-based, they literally called it more painful. So, yeah.
Okay, that answers my question.
Yeah. All right. Thank you all very much.
Yeah.
Slide change is scheduled.
All right. Okay, I'm Dave Neven.
I'm Rakesh Boba.
And we're from Oregon State University, and we want to talk about WOSOC. So, what's an WOSOC? It's a professionally guided, student-run managed security service provider. We serve underserved organizations across our geographic region. This includes local government, education, not-for-profit, and we're growing rapidly. Yeah, so what does that make us different from most other experiential learning programs in cybersecurity? Our curriculum, and that didn't come out right, is baked into the degree. It's not an internship. It's for credit. This is real-world experience. So they're providing services to actual organizations. We're not just about the tech skills. There's a lot of soft skills here as well. And we're based off of a clinical rotation model. So you've heard of, probably may have heard of these somewhere. So clinical rotations are used in a teaching hospital. So at our school, we have a veterinary medicine school. And in the 4th year of that vet med school, students undergo a full year of clinical rotations. I've talked to my vet about this. She found it very painful, but appreciated that they had that real world experience. It's all curriculum integrated. It's operated by, we're operated by professionally guided students, but it's that professional guidance. And we're the first cybersecurity teaching hospital in the nation. So a little bit of our history. I started as I was, at the time I was CISO at Oregon State University, and we started supplementing our staffing with students from the security option within cybersecurity to our team, because I couldn't keep full-timers at the salaries that universities can afford to pay professionals, especially back at that time. This started a relationship with people in the department like Rakesh, and Rakesh and I started talking about how can we make this available for all of our students. And so that's how we developed this idea for WOSOC. In 2017, we had our first student receive academic credit for work performed. And then 2020, we moved it to, and myself, to the College of Engineering. And a couple years later, we were ready to begin offering services to a select few organizations as a pilot. And then this ended up with us developing an entirely new cybersecurity operations track within our CS program degree. And soon, in this spring, we should enter scale up and have a formal launch. So our undergraduate curriculum, and I want you to know that Rakesh is not mute. He's able of speaking, but
I'm letting Dave kill
yeah,
himself.
yeah. But we decided we wanted to go through this quick, and he's at a higher academic rank, and you know how that goes. So we have a 4-course, 17-hour credit WOSOC practicum sequence that students undergo in their senior year. It's real-life hands-on experience in a working security operations center, 10 to 12 hours per week each term. We are on a quarter basis. They do clinical rotations in the various operational areas, which I'll cover in a minute. And they receive mentorship from professionals, experienced professionals in the field, and guest lectures from visiting experts. We have 7 faculty associated with WOSOC, and our average length of cybersecurity services approximately 10 years. Starting, it'll be 2 years out because we'll start recruitment to this program in the fall. We're going to have a graduate program around this, and this is really going to closely mirror the vet med full year of clinical rotation. It'll be a 12-month clinical rotation divided into 17 3-week blocks. And then we have 10 blocks of core, 6 blocks of specialization, 1 block of vacation because we don't want to kill them. and then hopefully a 6-week externship where they get to experience life in a different environment than just ORTSOC. Our current clinical rotations at the undergraduate level are network security monitoring, threat intelligence analysis, security engineering, threat hunting, penetration testing, and assessment. And so we're a little bit more than just a traditional SOC. We do some things that fall outside of that, but we want them to have the broader range of experience. So how students receive their grades for this. We have students, we give them credit for attendance and participation, of course, and then in each block, we have the mentors that lead those blocks provide them with a written evaluation. This would be like a performance evaluation that you would receive in jobs. And you'll notice that we take a lot of, we put a lot of effort into analyzing and encouraging more of the soft skills like communicating and collaborating with peers. We have a no cowboys rule. I'm sure people who have worked in SOCs long enough have a few cowboys over their lifetime. And this is a very positive one, and I'd like to point out that the pictures are of actual students that have gone through our program, but the sample student evaluation doesn't necessarily align with the pictures, and that's the case throughout. But this student, of course, did pretty well in this network security monitoring rotation. So our outcomes on the student level, students enjoy this experience most of the time. They do grumble. We just realized that through this program that this is the longest amount of time that the students have had with their particular instructors since grade school. So at no other time have they spent this many number of hours a week since their grade school, elementary school. So we like to think that they're professionally ready. They have a great combination of technical and soft skills. And our studies have shown that over time that students are typically hired into mid-level, higher paying jobs after doing this experience. Our research potential and directions. ORTSOC used to be an acronym until we outgrew Oregon. So it used to be Oregon Research and Teaching Security Operations Center. We also outgrew the SOC thing. But it gives access to real-world data for testing and validating new ideas. It's an easier opportunity to study human factors in SOC workflow, broad view of the threat landscape. I think this ties in, the first point ties in well to the earlier panel discussion. All of our clients sign a data release. There has to be some sort of pay for getting free services. And then it gives us a way to innovate and evaluate this as a new educational model. Collaboration opportunities, and we're particularly interested in well, we'd welcome all of you, but we talk to the academic side all the time. But for you on the operational side of things, are our students leaving with the right skills? Are you interested in students that are doing this for some externships or internship opportunities? Are there any ideas that you want to test out in a SOC like this? And of course, guest lectures, demonstration, and opportunities for mentorship. All right, so this will power off. This should go automatically.
Unless the transformation changed. But
yeah, probably
we were doing this in Keynote, and I don't know if the timer carried over.
So I will pretend to be the timer here.
And it is doing it.
It is doing it, great.
Okay.
So we're to our question point.
Yeah, a couple of things I want to add in terms of what we're looking for, and hopefully what, for this audience, what we bring. One, for you to be aware, the panel about data sharing was a big thing, and I can give you a little bit of history if we have time of how Matt's work actually started. It was done in the SOC, and we faced some of the same challenges that people brought up for the panel this afternoon. So what we're looking for is, we didn't put all the details, but in that one student evaluation, you saw the network security monitoring, the skills we test them on, evaluate them on. So are we teaching them the right skills, and you want us to see different skills emphasized? We would love to know. All of you bring a wealth of experience. I mean, I was thinking as we are going through the workshop, I would love each of you to give a guest lecture in our SOC. We do on Fridays, right? Bring your perspective, maybe influence the next generation of analysts, right? So those are the kind of feedback and collaboration we're looking for. So essentially trying to let it know that we have this going and we would love to collaborate.
Excellent. Eric Dahl, Deloitte. 2 questions. How is kind of uptake or demand, participation been so far? And what can industry do to help expand or accelerate?
Okay. As far as uptake so far, number of students, we're at our timing on the curriculum being approved ended up at a point where we have a bunch of students that these are all to their senior year. The curriculum all of a sudden changed, and so many of the students that are in the cybersecurity program were interested in taking this, but it would require that they return in the fall to complete their degree, and they decided not to do it. We're at 20 undergraduate students this year, and we let a few graduate students come in just on a trial basis. Our predictions from our advisors is that we're going to be in the 50 student range.
Next coming fall. Yeah.
And
our target is hopefully we're getting up to 200 students is what we hope in each cycle, depending on capacity constraints and such.
Yeah. And remind me of your second question.
What can we do to help, stimulate demand, help you guys scale?
Yeah, I think one of the things Dave mentioned, grumblings kind of stuff from students is because we also have an organizational SOC that they get paid to go to spend hours. Our SOC is curriculum integrated, so we're actually looking to create student scholarships, hopefully industry funded, so that there is a relationship, industry can come, check out these students for internships and stuff, so that's one way. But I think, we try and sort of tell them there's a lot of jobs in industry in this space, but actually I think hearing from horse's mouth is better than us selling it. So we would love for you to have and sort of, speak about the value of these kind of programs. And I think it's a cycle, right? The first batch of students do well. The next batch of students learn that this program is actually, helping students land better jobs and such. And so I think we are not there yet, but that's what we're hoping to create. Yeah. I don't know if that helped. Yeah.
No, it helps a lot. We'll talk later.
Yeah.
Hey, Jeff Johnese, also Deloitte, strangely enough. What is your tech stack that you're currently using?
Open source, because our clients have no money.
Neither do we.
So we're on Elastic for SIM. We deploy a sensor at each site. It uses a combination of Suricata as an IDS and Zeek, formerly known as Bro for some of the older people, as our network monitoring stack. Some of our clients already come with an EDS solution, and so we try to grab that data whenever we can. And for those who don't, Elastic has an EDS solution, and it's not the best in the world, but it's better than nothing. And I didn't say that to our Elastic sponsors. So.
Completely understood. And second question, if you'll indulge me, is what about gathering AD logs, DHCP, any of the firewall logs, other things that are commonly used within a SOC?
As we can. Some of our clients don't have some of those things. They rely on a...
Most clients don't start by wanting to give you those things.
Yeah.
Just,
yeah. Yeah, and then there are some, I mentioned that we have a large not-for-profit, with a large network capacity. They just redid their network. They're at a point that we can't put our sensors in place. Well, we can't put all of our sensors in place without an aggregation switch. They can't afford the aggregation switch. We can't afford the aggregation switch either. And, well, we could, but we would set a precedent, and we don't want to start down that path.
Again, common.
Yeah.
It's okay.
So we're doing more endpoint data with them and doing what we can, so.
Okay, yeah.
Yeah.
Thanks. I think a summary is growing pains, and
Yeah.
the clients we serve are really small. Our rule is we can't serve somebody if they don't have an IT shop, so at least they should have an IT shop. But most of the times, the clients we take on just barely have an IT shop, and they have nothing for security. So and that's a space I think that's valuable because we provide valuable service while providing experience. Because anywhere else we go, we're competing with companies, which we don't want to be in the space up. Yeah.
Our CISO people have disappeared, but I don't know how many people are familiar with the Albert Sensor program through MSISEC. It's similar to what we do, but one of our clients was, they got offered 24/7 monitoring through the Albert Sensor program, and the price was going to be $10,000 a year, and they couldn't do it. So, yeah, that'd be a large percentage of their IT budget.
Do you have time for one more? We have time for one more question? Yeah. So, stupendous work. I really appreciate, and I can fairly imagine how much work it is to put this together. So great credit to you. One curious question. So you said externships. Mm-hmm. What are your externships like?
So we haven't done externships yet. So that's planned for our graduate program where we do the 6-week externship. The difference between externship is that they're not necessarily paid, and they're shorter in duration than a typical internship. We want to have a continual flow of students into an organization for that. Now, if there's some distance for the student to travel, or if it's in a different location, we would love to have those students at least put up and fed or something, but maybe a little remuneration, but it's something that we're willing to work with the organization on.
So if I want to bring one of your graduates into my SOC, what would it take?
A graduate, you just need to hire them.
Graduate students or graduate?
Graduate students. Just get in touch with us, and as we work out the program, we would love to send students to your SOC.
Because it's easier for me to hire temporary people than permanent staff, but I can create one long-standing temporary and rotate through as many students of yours as possible.
Yeah, that's what we're thinking. Of a way of doing that. We have one small city that they were remodeling the upper story of their city hall. It's a really small city, and we're going to turn it into apartments for interns, and things like that. They can't afford to pay much, but at least they can provide room and board, and the experience. And for some students, that's great.
Yeah, our externship program, I think, is flexible because it's still in the works, so we can talk details of what works, because when we shop this around to some colleagues in industry, they're like 6 weeks is too short. We wouldn't want to onboard anybody to lose them in 6 weeks. But at the same time, we want to make sure that it fits within our rotation cycle, so we need to figure that out.
Yep.
Right. So that is going to be my next comment, that every SOC is a little different. Very hard to train somebody for a generic SOC and then expect them to be able to be effective on day one.
Yeah.
So this is an onboarding process all SOCs have, and so that's something you'll have to negotiate.
Just so you know, for our SOC, we originally designed our onboarding period to be 4 weeks of the term. We cut that back to about 1.5 weeks to 2 weeks because they already came in with the technical skills, so the ramp-up time was faster, and basically they were learning more of our operational processes and rules. than just how to get into
I'll give you one cheat. So most SOCs are looking for some specific ability. They find a person with that ability, no onboarding required.
Yeah, exactly.
Yeah, we would love to know what that ability is so we can maybe train them. Yes.
Yeah.
Yeah.
Okay. All right.
All right. Thanks.
Thank you.
Thanks, everyone.
They say it's always 5 o'clock somewhere, but unfortunately not here just yet. So listen, we've reached the end of the talk today. I just wanted to say, actually, can we get a round of applause for all the speakers and the panelists today? Just really, really amazing talks. And one of the things that I'm most excited about is that several of the people that are in here that gave talks today that are sitting in the audience were here last year when the room was just a fraction of this size.
Tripled.
Yeah, tripled. And so I'm really excited about the community that we're building here. I think there's some really important problems. We've had some, great questions today, great topics today, and I'm looking forward to next year. Mike?
That's, you know what, Nolan said all the inspiring stuff, so I'll just cover the boring paperwork stuff. Okay? So, by the power invested in me as the co-chair of the conference is now over. Go in peace to serve the SOC.
We have time for one more question from Raj.
Oh, yes, Raj, come on. Question.
So I was just talking to somebody over lunch that, as far as I know, this is the only workshop or conference on SOCs. Can you confirm this?
So there is, so I was looking through some of the slides that that Sandy was showing earlier today, and one of the sources mentioned that they'd done like something at a first conference or something on it, but I have to hunt that down more. There may be, but if there are, it's very, very well hidden.
You mean academics?
Period.
Science.
Yeah, sounds true, yeah.
Yeah.
No.
Academic, yeah. Except for those that go to the sciences of college.
Well, and I think this year too, the topics have converged a bit more. I'm seeing a lot of topics that are crossing over between the academic research, the industry research, and what we can do to better. I think we've got a long way to go, which is why this will be a long-running series of workshops. But I think we're even closer than we were last year.
I think so. I think this has been a significant step. We're doing it once is luck, twice is skill. So.
And it needs to be said. I mean, I had a tremendous amount of fun asking questions and listening.
I gathered you were having some fun asking questions, Raj. So the only things of note, our email addresses are on the front side of the presentation.
The Google Sheet.
So the Google Sheet is available. The URL is in the Slack. I fixed the permissions. So there's like 6 people who've signed up, which is clearly an indication that I need more people to sign up. So sign in the sheet. Yes, go ahead, Seth.
Where can we find the link to the Slack?
It's in your, you got a dashboard link when you registered for NDSS, and there's a link to the Slack there. Robin is not here, so I can't ask him how long the Slack's going to last for. So let me put it this way: if you didn't get the QR code, use the Slack. If you can't use the Slack, we have email addresses. Mail, okay. We are interested in anyone who wants to serve on the PC next year, because we'd expect that maybe we'll get 50 submissions next year. That'll be really exciting. We might actually be able to go on Monday and Friday.
Nice.
Yeah. So I don't think there's anything else. I'm sure many of you have got to fly, so especially for those of you who are left, thank you for staying. This is more than I expected. I expected there was going to be like 2 people left and there was going to be us.
You did threaten to bar the door.
That is true, and I am a very large man. So, okay. All right. Thanks, folks.
Yeah, thank you all very much.
Yeah.